Okay. Yeah. So let me share my screen. So where will you share it? Yeah, I'll share it in that same sheet, right, where we share all the other resources. So we will share there. So 1 second, let me share my screen. Uh, just give me 1 second. Okay. Yeah. So not this, not this, not this. Yeah. So let's start with the most recent one. So yeah, for the people joining for the first time today, so we have covered all the first 5 weeks topics and then doubts in the previous sessions. So today what we will be doing is we will be going over the previous year's questions for the quiz fund. So let me start with this one.
Shan, this recording will
Yeah.
be shared?
Yeah. So I've recorded. So I've started the recording. So after
Okay.
this session, I'll get the recording in like 1 hour or something. So I'll put it in that sheet, Google Sheet.
In the drive, right?
Yes. Yes.
Yeah, okay.
Okay. So yeah, Bhanu Pratap, can you mute when you're not talking? Yeah.
Sorry.
Yeah. No, that's fine. Okay. So the first question here is this one. Right? So although we saw this
Do
yesterday
increase the
also.
font size.
Yeah, let me zoom a bit. Yeah. So we saw this yesterday also, so we'll see it again. So here the question is, by using the information provided below, which line prints the process ID? So not just the process ID, but prints the line with the process ID for the command daily backup. The command is only exclusively started by the current user. So you can see here, the three outputs are given: outputs of PSX, output of PS, and output of PSAUX. So in the output of PS, we don't see the daily backup being listed. Right? So you can see the daily backup here, which is there in output of PSX, but it is not there in output of PS, and it is not there in output of PSAUX. So as you can see here, only the other things are there. So we cannot use PS or PSAUX to get that line at all. We have to use PSX. So PSX now gives all these outputs. So out of these, I need to filter out only this line, right? So if I want to filter out this line, then I'll have to use something like grep. So here, as you can see, both the lines, all the other lines are fine. So if I search for daily backup, these lines will not be printed. But you can see this and the last line both have the word daily backup in it. So this is daily backup earth.sh, and this is daily backup. So if I just search for daily backup, then it will filter and give me both these lines, whereas I just want this line. So what we also use is the regular expression, which is the \b. So 1 second, let me close this and let me open another one. Yeah, and let me also open a terminal. So here, as you can see, we are having this. So let me just demonstrate on a simple file. So let me open the VM, or let me just be here itself. I'll not open the VM for this one. I'll just do it on my local system. So let's say we have a file where we have something like this. So like home slash something something, and we have this daily backup, and we have another line which is daily backup .sh, and we also have some other lines. So what happens is let me show that also. So if I show the file, that is this one, and then so if I take this file and if I grep out daily backup, so you can see both the lines will be there. So daily backup and daily backup are. So the other lines are filtered out, that is fine. But then to get only this line and not the line with something else, what we can do is we can use the regex of the word boundary. So I can use the \b here, which means a word boundary. So here we have a word boundary because the word is ending here. but here it is not a word boundary. So now only this line will be printed. So that's why in here, so
Sir, instead
yeah,
of this, can we use head minus one?
head minus one will give you the first line.
No, no, no.
So
After cat temp.
yeah, so here if you do it, it will give you the first line. But if the order was reversed, then it will not work, right?
Yeah, then we can use tail minus one.
So you will not know what is the order when you are running it, right? So you will have to write something that will always work. So if it is in the first line, you can use head minus one. If it's the last line, you can use tail minus one. If it is like say 1,000 things which have this, and you just want to get like 784th line, so you have to use a generalized solution, right? So here this will work always. So it will only give the line that has the word daily backup and nothing which is like afterwards daily backup. So if I want to not have anything on the left also, we have to use \b on the left also, right? So if you see, if I change the file, so let me have another line here, which is like something else is there. So now if I do this, so if I do just daily backup, it will print all the 3 lines. If I use daily backup \b, it will print, sorry, we have to put it in the quotes. So this will print both this and this also, because in the end we have word boundary for both of these, but in the starting we have not checked for word boundary. So what we have to do is we have to add the \b in the starting also. So then it will just give me daily backup. So in this question, firstly we can see that PS and PSAUX don't have that line at all. So obviously we cannot use that. So in PS, we use the grep and we search for daily backup along with the \b. So here you can see there are these options. So this one which uses PS obviously is wrong, and this one which uses PS AUX is wrong. So this one seems right because we are doing PS and then grep daily backup. But as you see that if we're just searching for daily backup, it will give both of these lines. So that's why we have to actually do it like this. So PSX grep, and we can not have the whole path also. We can just have daily backup and then \b. But yeah, so this will also work. So we are matching for the line which is exactly this one and not the next one.
Sir, this word boundary also work before this backslash. I
Sorry.
mean, yes, this backslash create a word boundary.
Yes, \b means a word boundary. Yes.
Not this. In input, there is a home, then backslash, then Vidya,
No,
and
these are
now,
/, not \.
sorry, this
Yeah.
forward slash.
Yeah.
Uh, I want to ask you that bin and daily backup both are different because there is a forward slash. Should it not be counted in the word?
No, so we are searching for the entire thing. So we are telling that home vidya.local bin daily backup. This entire thing, like print the line that has this exact thing, and nothing before it as part of that word and nothing after it as part of that word. So here you can see this and this line are exactly same till backup, but then there is something else also. So this \b is telling not to take this one because here it is not a word boundary, whereas here it is a word boundary. And similarly on the left side, it is a word boundary.
No, I understand this. I only ask that the space create word boundary. Also, this forward slash also create word boundary.
Okay, yeah. So let us check that, right? So here you can see that we have searched for \b daily backup \b. So it is matching this one, right? So this backslash is also giving us word boundary. So anything which is not alphanumeric and yeah, alphanumeric, that will give you a word boundary. So we can see this. 1 second. We go to that DRE versus DRE. So next. \b, it should be okay, it's in the next page. Okay, actually I think we skipped it over. Should be somewhere here. Okay, no, I think we did not miss it. So let us go forward. Yeah, so here you can see matches a word boundary. That is matches for if the character to the left of the word is to and to the right of the word is a non word. So here what does this match? It matches the alphanumeric characters. So A to Z small, A to Z capital, and then 0 to 9. But then punctuations like this forward slash will also not match it. So here, if you're searching for word boundary, daily backup word boundary, then this is matched because this
I
is daily
understand.
backup word boundary.
Word means alphanumeric characters.
Yeah.
Hmm.
Okay.
You can
So
proceed.
yeah. So this is the first question. So that's why the fourth option will not work, and only the first option will work.
Sir, why cross sign is included?
Which one?
PS cross first option.
No, this is the letter X. So as we saw, there are three things we are seeing: PSX, PS, and PSAUX. So PS output, we can see that daily backup is not mentioned, so we cannot use PS. And
Yes.
PSAUX also daily backup is not mentioned, so we cannot use PSAUX. So only
Just
PSX
random.
output has that. Yeah, no PSX. This is a flag. So this is a flag to PS. So you can see in man PS. So there are multiple flags that you can give. So X means lift the VSG style must have a TTY restriction. So even commands that are not run through a TTY will be printed. So PS has a lot of these flags, so you can go through these. But then here it is already given. So the output is already given. So you can see that PSX is having the output which we want, right? So we use PSX and then we filter on that instead of using PS.
Okay, sir. Got it. Sir.
Yeah. Yeah, Devasmith, you have your hand raised. Hello.
He is asking Google Sheet link in chat.
Oh, okay. I didn't see the chat. So this one just made like this is also there in the like Discourse pinned post. So you can keep this pinned. Okay. So yeah, let's move on. So the next question is this one. So here select a command from the given option, which will find and print a number hidden in the text comprising of A to Z, comma, and dot. So these are the symbols which are there in this. As you can see, comma is part of there, dot is there, and capital and small letters are there. Note that there is only one numeric character, while the rest of the characters are either alphabets or punctuation. Command which prints only the number and not text. So we have to write some grep command which will go through this and only print that number. So this is your first hint, right? So only print the number. That means we use the -o flag. So the grep -o will print only. So you can see even help is given here. So you can see grep -help, and it is all they're also reminding you that -o is the flag to do that. So here we have a few options. So we have grep v A to Z, comma, dot, hidden number. So V means the inverse searching. So search for something which does not match this. So this will work. So it will match that line and print that entire line. But I just want to print that number. So second option is totally incorrect. So this will match everything except the number. We need the -v. The third one is correct. So this will match the number, but this will also print the entire line. So we don't want that entire line. So the fourth one is the only correct option. So this will match the number and it will only print that number. So there is another correct option. So if you did this grep -v A to Z, comma, dot, hidden numbers, and we also give the -o, so that would also be a correct option. And this is also a correct option. So you either match 0 to 9 digits, or you invert the match of A to Z, comma, dot. But then whatever you do, you have to use the -o to only print that match. Okay, so
So
the
if we want that particular pattern, we don't want the complete line. What to do then?
this -o,
-o.
yes.
Okay.
So you can see the help is also given, right? So a -o or dash only dash matching, it shows only non-empty parts of line that match. So it does not print the entire line.
Okay, sir.
Okay, so ISO 86001 date time format are shown below. So this is basically three types of three lines, and you have to from the options select the correct extended regular expression. So it has to be ERE and not BRE. That will match with all of the given formats. So here you can see some format is similar. So let me screenshot this. Wait, let me first zoom it in. And let me screenshot this. Okay, so in here you can see that some format is same. So this year 2022 it is there in all of these. So this means that we have a digit. So year will obviously just be digit, right? So this is 0 to 9, and year is always 4 digit. So this will have to be 4. So we mention how many to match using this curly bracket. So we have to match 0 to 9, 4, and then in this one we have a dash, in this one we have a dash, but in this one we don't have any dash, right? So the dash might be present or the dash might not be present. So a dash can be present or cannot be present, but it can never be present more than once, right? So here we use the question mark, which means present either 0 times or present either 1 times. So then we match again 2 digits, so similar to this. So again 0 to 9, and this time we match it only for 2 digits. So this will be 2, and that is same for all the patterns. So then again the same thing, right? So again dash question mark. So dash can be present or not be present. Then again 0 to 9, which is present exactly 2 times. So after this, so we have done till here, here, and here. So after this we have this t. So the
So
t is always,
sir,
yeah, sorry.
for dash, can we use square bracket, then dash, then pipe symbol, and then 0?
No, right? Because what you're telling is square bracket dash pipe 0. So two things wrong with this. So first of all, if you want to use pipe to mean this or this, you don't use square bracket, you will use the round bracket. So square bracket means any of these symbols. So if you're using square bracket, this means match either dash or pipe or 0, which is obviously not correct. And even if you're doing round bracket dash pipe 0, which means either pipe or 0, so then it will not work. So what you're doing is you're matching either pipe or this 0, but this 0 we are already matching using this, right? So 2 digits. So this can be 0, this can be any other also. So if it is some other month, if it's month 11 or month 12 or month 10, then it will be 1, it will not be 0. So you cannot match like this. So this month is always the same. So you can see this part of this part of this is same as this part of this. So this you will match separately like this. So this dash can either be present or absent. So that you are matching with the question mark.
Okay, sir.
Yeah. So we come till here. So now the t is always present. So we just simply write the t. So after that, this timing, right? So timing, again, similar thing. So you can see 2 digit will always be there. So again, it is 0 to 9, and then bracket 2. So 2 digit. And then we have a colon in the first 2, but then not here. So the colon can also either be present or not be present. So this also we will use the question mark. And after that, again, the same thing. So basically this, let me just type this. So again, 0 to 9, which is present either, which is present 2 times. And then again, we have this colon. So again, colon, which may or may not be present. And then the second, so again, the same thing. So which is 0 to 9. And 2 characters exactly. So after this, we have either this part, which is plus 0, 0, colon 0, 0, or we have the letter Z. So here we can use the round bracket, which you were talking about, right? So we can use the round bracket, and we can say either match Z or match 0, 0, colon 0, 0. So if you want, you can also like make this like this. So 0 to 9 bracket 2 colon 0 to 9 bracket 2 to make it more generic. But then here, like if you're matching this also, it will work for this. So here you can see that the options basically are the same thing. So instead of the question mark, here they have given star, here they have given plus, and here they have not given anything. So obviously this one will, the last one will obviously not work because it will not match for the last line because the dash is not there and it has told it has to be there compulsorily. So the first one, so the star will work, but then as you can see, it will also match for 2 dashes, 3 dashes, etc. Whereas we just want to match for 1 dash. So instead of star, we will use the question mark. And the plus obviously will not work because plus means 1 or more. So this will never work for the last line. So plus is out of question and the fourth option is out of question. So I think there's also another thing different in the first and third one. Okay, no, it's mostly that. So instead of question marks, they have used stars. So the star will work to match 0 or 1, but it will also match more than 1. Whereas we just want to match either 0 or 1. So that's why we are using question mark. And at the end, it is either Z or plus 0:00. So here we have to escape the plus because we are matching a literal plus. So otherwise, plus has the special meaning of 1 or more. So we have to here now backslash plus to escape the plus, so that it is actually matching the literal plus symbol in the line. Right. So just let me know if
Sir?
this was clear. Yeah.
So here in the first option, asterisk symbol means matching 0 or more time, right?
Yes. Yes.
Okay. Plus means 1 or more.
Yes.
Okay.
Question mark means 0 or 1.
0.
And this just means only 1. So it has to always be
Okay.
there. So this will not match. Plus will also not match the last line. The first option and the third option will work for these, but then it will not work for if we have, let's say, 2 dashes, which should not be matched. So this is the best option because we only match either if it is there or if it is not there, not more than 1.
Okay, sir.
Yeah. Okay, so the next one, following code shows the command ran in the terminal. What will be the output of the last command? So PS tells you this, and then PS grep $. Right. So what does $$ do? Like, what is this $$?
Process ID.
Process ID.
Yeah, the
PID.
current bash's process ID, right? So the
Bash.
current bash shell's process ID, if we are grepping, so obviously the bash, there is only one bash, right? So this one, the first line. So it will only filter out. So out of all these, it will only print this line, the 64754 PTS-300. So you can see this is the answer, 64743. So whatever is the process of the current bash shell, that will be grepped. So only this one is matching. So that will be printed out. Right, so this might be confusing with this option. So you might think this will give the process ID of the PS, but no. So this is a variable which always stores process ID of that bash shell only. Right. Yes. So next one, what the following for loop will print at the end of the execution. For file in find in the current directory, maxdepth1 name start.txt do echo $basename $file. So let us break this down one by one. So here, this is a for loop, right? So hopefully you already know what for loop is. So this is the variable which will store the value in each iteration, and this is the like the entire array that will come. So here these backticks mean that execute this command and take the output and iterate over it. So the command is find dot, so find in the current directory wherever I am, dash maxdepth1. So it will not go recursively, right? You can see if I am, let's say, so let me go to maybe one step up. So here you can see I am currently in this TMP folder. So if I do tree, it will not only print whatever is in that folder, but whatever is inside those folders inside there also. But what we do is we use the maxdepth1. So it will only print what is in that directly under that folder. So only the folders that is directly inside there. So maxdepth1 is similar to how ls works. So it will only print the files and folders present in that current directory. And dash name means I'm filtering out only those files.
One doubt, sir.
Yeah.
You know what is maxdepth, but in paper we don't know what is maxdepth. How to do this question?
Yeah. So if it is told in the question, like sometimes it is told, but then here it is not told. So it's not that you know or I know, but then find is one of the commands which is part of the syllabus, right? So some command line utilities, it is there. Find. So yeah. So max depth you can even infer from the name, right? What it means. So max depth means the maximum it will go. So because find will recursively go inside all the folders. But if you're using max depth to some value, so it will stop till that. So kind of like how tree traversal works. So it will
Sir?
only, yeah.
So if here suppose max depth is not specified,
Yeah.
then how will it search?
So then it will not only get for the current directory, but everything inside that current directory also. Right. So let's say you have so you are in the current directory, and there you have 3 folders, A, B, C. So it will go inside those folders also. So whatever is inside those folders, and maybe there is again another folder. So whatever is inside that folder, it will keep on going inside until it finds files. So it will search for all the files in there. But if we have max depth
Okay.
of some value, so it will go only that many times. So max depth 1 means it will search for only what is directly inside that folder.
Okay. If we don't specify, it will go recursively.
Yeah, so that it will basically be infinity. So go as much as possible.
And if there is a double dot after find,
Yeah.
then does that mean it will start from the parent directory?
Yes, exactly. So dot means current directory. It will start from here. But if you use dot dot, then whatever was the folder in which I was, it will start from there. So all the other.
Okay, it will start finding from parent directory.
Yes, yes. So it will basically,
Okay.
if you're using with maxdepth 1, it will say this folder's name, then the other sibling folder's name.
Okay, sir.
And so dash name start.txt basically means that it will list out only those files or folders that have so that end with .txt. So if there are like multiple files or multiple folders, so only files and folders that end with .txt, those will be returned by this find command. So now we are iterating over all those one by one. And now we are using this basename command, right? So what the basename command will do is it will, so if you have a path, right? So let's say there's a path, so /a/b/c/d.txt. So what basename does is it will take the entire path and give you back only the file name. So this will be done by this basename command. And similarly, if you want the rest of it, so the rest of the path, then we have the dir name command. So if you have the entire path, you can get just the file's name using base name, and you can get the rest of it with dir name. So here we are calling the base name, and we are giving the path of that file, and we are just getting name of the file. So this is basically the same as doing ls start.txt.
Sir, this dir name will always print absolute or relative path.
Which one? Dir name, it will, so whatever you're passing to it, right? So this does not know anything about paths, it only knows about text. So if you give it any text like this, which has these forward slashes, so it will take till the last forward slash and give you as dir name, and anything after that, it will give you as base name. So find.
I think it cut by the forward slash and print the last word.
Yes, yes, exactly. So this will basically be the same as echo start.txt or ls start.txt. Okay, so it will tell you all the txt files in your current directory. So here the options are print the file names of all txt files in current directory recursively. So this recursively is wrong because we are using max depth 1. If we did not have this, this would be correct. Then they print the file names of all txt files in current directory and in immediate subdirectories of current working directory non-recursively. So this will be true if this was max depth 2. But because we have max depth 1, that's why this is true. Print the file names of all txt files in current directory non-recursively. So it will not go any further inside folders. It will only see in the current directory. Right. Okay. So let's move on. So this one, which of the following are true statements for hardlinks and softlinks? So hardlinks of a file has same inode number. So hopefully like this is already clear. So softlink of a file has same inode number. So no, softlinks do not have same inode numbers. Softlinks have different inode numbers. Hardlinks do have same inode numbers. Softlink of a file occupies the same space. So this is also wrong. So it does not matter whether the original file is 1 KB or 1 MB or 1 GB. Softlink will always be like around 1 KB. So it will basically just take enough space to store the path of the file. So it will not store anything else other than the path of the file. So softlink will always be small size. Hardlinks cannot be moved to a different file system. This is true. So if you remember the week 1 content, so hardlinks can, so softlinks can be there across file systems, whereas hardlinks has to be only inside the same file system. So hardlinks cannot be done on directories and hardlinks cannot be done on different file systems. And then a soft link of a file unconventionally requires full path. So this is also wrong. So soft link can be done using relative paths. Right? So you can tell you can create a soft link which points to the parent directory and then a folder inside the parent directory and then a file inside that. So if you change even the location of the soft link, then also the soft link will be broken. And if you change the location of the file, then also it will be broken. So maybe we can see that quickly. So yeah, so let's say I'm currently in this. So let me go inside one folder. So I'm currently in this folder called 26. So currently I don't have anything. And if I see in the parent folders 25, I have this temp file, which we just now created. So if I create this ln-s soft link to that /25, and I name it, let's say soft. So now you can see the soft link is there, and then it is pointing to /25. But now if I obviously move that or change that name of the original file, then obviously this will be broken. But even if I now move the soft link, then also it will be broken. So let's say I create a folder test2, and then I move this soft link from the current place into test2/soft link. So this has now moved the soft link from here to there. So if you see, so currently in our current directory, we have test2 folder, and in there we have soft link. So soft link direct just stores whatever path we gave it, right? So we gave, while creating the soft link, we gave the path /25. So it is still trying to find something in its parent directory /25. So if you see now, if you do ls, so you can see this is now red, right? It is broken. So now it is still trying to find something in this relative path, the /25, which is no longer there. So the relativity of the path has to be maintained. So you can give a relative path, but then that has to be there even after, if there is some change in either the original path or the soft link, then that will be broken. So soft link does not require full path. We can give relative paths.
Sir,
Yeah.
so what is meant by different file system?
So different file system means, so you have your disks, right? So in your Windows, you will have C drive, D drive, E drive, etc. So those are separate partitions, right? So it might be you have one hard disk and then you have 3 partitions in that hard disk, or maybe you have 3 different hard disks itself, right? So regardless of how many hard disks you have, you can create partitions in those hard disks. So each partition will have its own file system. So you can think of this as hard links cannot be moved to a different partition. So if it is on a different partition, then hard links cannot be created. Only soft links can be created.
Okay, sir.
Yeah. Okay. And changes done in original file is reflected in hard link. So yeah, obviously. So both in soft link and hard link, the changes done will be reflected. Okay. So here the question is in this so the following while loop, select the standard inputs from the following options that breaks the loop. So here basically it's a convoluted way of asking which of the given patterns match this pattern, right? So you can see here while read line do, and then we are storing a regex pattern in a variable, and then we are seeing which of these match. So for each line, we are going over the lines one by one. So we are while loop, and then each time we are reading the line, and in each line we are seeing if that line matches this regex pattern, right? So this equal to tilde is a way of matching regex. So this can be done only inside this double box brackets. So if that is matching, so if a line is matching that regex, then we are breaking. So we are asking for which inputs this will break. So obviously we are asking for which inputs this pattern will be matched. So the pattern here is any character between 0 to 3, followed by any character between A to G, followed by any character 1 or 2 or 3, followed by any character X or Y or Z. So here in this options, you can see the first one, we don't have any character between 0 to 3 itself, so it is not matching. In the second one, we have this, which is 3 is matching 0 to 3, G is matching A to G, 2 is matching 1 to 3, and Z is matching X, Y, Z. So this one matches. Here also there is nothing that matches. So here this one, you can see the 2 matches, but then J does not match. So J is outside the A to G range. So J comes after G. So this will not match. Similarly, here also it will not match. So here the first few numbers are not matching, but then this one, 2A 1Z, that matches. So this 2 is matching 0 to 3, A is matching A to Z, 1 is matching 1 to 3, and Z is matching XYZ. So this one is matching, so this line will be matched. And the last one also, there is, so this one obviously will not match, and then no other also matches this pattern. So
Sir,
yeah.
1 minute.
Yeah.
For the matching, like we did do in Python, double equal to. Here we use equal to and tilde. What is the sign for not equal to?
No. So this is not equal to matching. This is regex matching. So this will match the regex. If you want to just compare if the two strings are equal, then you simply use equal sign. And for not equals, you use semicolon equal sign, same as
Okay.
Python. Yeah, and for
Is there
regex
anything
matching,
if we don't want to match, I mean, if this line was not match this pattern.
okay, yeah. So that you can use an exclamation outside this box bracket.
Okay.
That
So
will
there is
invert.
no ready-made operator for not.
No, there's nothing for not matching your regex.
Okay.
So you can like put the entire regex in that cap thing. That will also work if you want that. But yeah, ideally you can just put an exclamation outside, so that will invert the matching.
Thanks.
Yeah. Okay. So the next one is which of the following options
Sir,
contain?
one doubt, sir, previous question.
Yeah.
0-3 means it can be 0 or 1, or it can be 0, 1, 2, 3, anything.
It can be 0, 1, 2, 3, anything in that range.
Okay,
So-
and can we write like this also? 0, pipe symbol 1, pipe symbol 2, pipe symbol 3, like this also?
You can, so let me write it down 1 second. So what you can do is you can,
And for example, my basic question is you have written XYZ. Can I write it? It's like X pipe symbol Y pipe symbol Z, like this also?
yes. So the not in the box bracket. So see, one thing you can do is you can do 0-3 like this if it's consecutive, or you can do inside box bracket, you can do 1, 2, 3 like this, or you can do inside round brackets 0, pipe 1, pipe 2, pipe 3.
And sir,
Okay,
also, if you have time, can you explain 2 round brackets, single square bracket, 2 flower bracket, single flower bracket? What are these difference and when to use which one?
Yeah, so 2 box bracket, this is not part of regex, right? So 2 box bracket, we use it while testing things. So if you remember in the session where we are talking about test, so test is a command which tests things. So we can
True.
use either test or these.
Comparison, we can say.
Yes. So we can use the single box bracket and the test. And there's an advanced version which is double box bracket, which can do anything these can do, but it can also do things like this regex matching. Right, so we cannot use single box bracket for regex matching. So there we have to use the double box bracket.
And
Yeah,
double circle, this circle bracket is used for mathematical operation, right?
yes. So if you're doing it inside, like in bash, then this is for mathematical evaluation. So you can do things like some variable plus some value, etc. And if you
But
want to
for
get
this,
value,
in
you can
starting,
use-
we need to use dollar sign, right?
Yes, so if you use the dollar sign, then the value will be returned. So you can do things like echo. But if you just want to execute this and not run it, so let's say, for example, if you just want to do I++, you don't want the value back, then you can omit the dollar sign.
Okay, and if I want to store it some variable, so I need to use dollar sign, right?
Yes. So let's say you want to do like where 2 equals the value of ++ I. So then you have to use this dollar sign.
Okay, and this single square bracket, when to use this?
So single square bracket, you can, if you're talking about this one here, when not in regex, but then actually in bash. So you can use single or double interchangeably most of the times, but then double is basically like a superset. So it can do some things like regex matching. So here you cannot use single square bracket. So ideally you should always use double square bracket and not use the single square bracket. But even if a question comes with single square bracket, so all the things of double will work except regex. Regex will not work.
Okay, sir. Thank you so
Yeah.
much.
And inside
So
regex, yeah.
So regular expression for that thing, we have to always use double square brackets, right, sir?
Yeah, so if you want to compare regex like this, right? So $line equals tilde $pat. So if you want to use this equals tilde operator, then you have to use a double box bracket always.
So here, can I
Okay,
also
okay.
use dash EQ also?
No, so dash EQ, so for two reasons that is wrong. So first of all, dash EQ only works with integers. So you can only compare integers with dash EQ. And secondly, you can use the dash equal to sign to compare two strings. So dash EQ is for integers. If you want to compare one int with another int, so you can use dash EQ. If you want to compare one string with another string, you can use equals. But here we are not comparing if two strings are equal, right? We're comparing if this string matches this regex. So then we use this equal tilde. So if I want to check if the line is exactly this thing, like literally box bracket 0 minus 3, then we use the equal to. But here we don't want to compare, right? We want to see if it is matching this regex. So the right side will be treated as a regex, left side will be treated as the string on which to match the regex. So then we use this. So this will be regex, and this is string. Then we use the equal tilde. And the dash EQ is only used for integers. You cannot use it for strings.
Can you again explain the third part, that string equal to tilde sign?
Yeah, so here this pattern is a regex, right? So you are trying to match if this regex match this line. So you are not trying to do equality checking. So you are not checking if apple is equals to apple. So if you are checking for string equality like this, then you use the equals to sign. But here you are using some regex. So you're seeing if some string like apple is matching this pattern, which is, let's say, starts with A or something like that. So some regex you want to match. If you're matching regex with a string, you use equals tilde. If you're matching string with a string, you use the equals sign.
Okay, sir. Thank you.
Yeah.
And all of these three should be contained in double square bracket or
Yes.
single square bracket.
Yes. So double square bracket you can use for all these, and single
Except
square
this
bracket. Yeah. So single square bracket you can only use for this and this, and double square bracket you can use for all the three.
Yes, understood.
Yes. So this will not work in single square bracket. Okay. So yeah, let's continue. So hopefully this is clear why these two are matching, others are not matching. So just be prepared, like with regex. So even if like some other regex is asked, you should be able to quickly find out which one is matching. So here, okay. So here what we have to do is which of the following option contains commands which will output calendar for October and November. So here let us execute and see which one works, right? So here you can see there are multiple options. So we have echo cal. So this, if you remember, is part of week 2, right? So brace expansion. If I just do 10, 11, so this will basically expand to both the numbers 10 and 11. So if I do cal and then this, so if I do echo cal and then 10, 11, and then 2023. So what this will do is this will just print the words cal and then all this. So if I do this, what this will do is print cal 10, 11, 2023, right? But now, as you can see, there is a backslash here. So what this backslash means is I am escaping the spaces. So it is, you can either use backslash or you can put the entire thing in quotes. So both of them will do the same thing. So what that means is don't treat these as separate arguments. This entire thing is one argument. So now if it is splitting, it will split into two things. So it will be cal 10 2023 and cal 11 2023. Okay, so quotes I think will not work in this one. Yeah, so you have to use the backslash. Yeah, sorry. Yeah, so here
we can use backtick also, maybe.
no backtick. So here backtick is for executing something, right? So here I just want to print this string. So cal 10 2023 and cal 11 2023. So here backtick will not work. So if I am using this backslash, so we are basically telling that this entire thing is one argument, and also expand 10 and this into 10 and 11. So basically this entire thing will be present two times. So cal 10 2023 and cal 11 2023. So it's like a permutation combination. So we can add multiple things also. So if I here now add, let's say a dot let's say C, so it will create all the combinations. So cal 10a, cal 10b, cal 10c, as you can see, 10a, 10b, 10c, 11a, 11b, 11c. So we can nest all these and it will automatically create all those possibilities. So here, if we are just doing this, it will just create two possibilities. So cal 10 2023 and cal 11 2023. and at the end there is a semicolon. So if I want to actually print a semicolon, so as you can see now, this will print cal 10 2023 semicolon, cal 11 2023 semicolon. Right. So this thing, this is just a text, right? So if you're just printing this, this will just print it to the screen. So now we can use the backtext, as you said, right? So if we are putting this in backtext, so which means I want to actually execute this. So then you can see it is trying to execute it. So now it is telling that it is not working because we have two things. But if I, let's say, remove this 11, and if we just do this, then so let me remove these brackets also. If we just have cal 10 2023, then you will so cal will work. So I don't know why it's not working for this.
So can you remove backslash and then try with
No, sir,
Yeah.
this semicolon.
remove backslash
Okay,
and then
yeah,
try with
yeah. Let's see this. Okay, yeah. So you can see, right? So 1 second. Let me zoom this. So if I do cal 10, so this one should be maybe like this. So yeah, we're getting the calendar. So now instead, let us do what was happening here. So if I just do echo this, then it will just print this. But now I want to execute these one by one. So this first option, this will just print it to the screen. So this is obviously not correct. We actually want to execute and get the calendar of 10 and 11, which is October and November. So the first one, if I just put it around one curly bracket, so let's do that. So what happens is we are getting an error. So this is because there are two things, right? So we have cal 10 and then cal 11. So when it's expanding inside one curly bracket, inside one round bracket in dollar, it is not able to run. So it is telling that cal is telling that this is not how you run cal. So what is the difference between this second one and third one is that we are doing the same thing as first one, but then we are piping it to bash. So each line we are sending it to bash as the std in. So if I do this, it is just printing this. But now if I send this to bash, so we can send any command to bash and it will execute it in a non-interactive mode. So now this entire thing will be run in bash. So now you can see it is executing each of these and then printing, right? So it's the same as running this thing. So cal 10 2023 and then cal 11 2023. So it's basically running this thing in bash and then returning. So if I am doing this and piping it to bash, then it is running and showing us the calendar. So this option is correct. And this nested option is will also not work because first we are running this internal one, which we already saw will not work. It will give us an error. And then if you are running that error as a command, that will also obviously not work. So like any random string, if you're trying to execute as a command, it will not work. So why the fifth one works? So here we are using the eval. So eval, if you remember, let me get the help page. So eval executes argument as a shell command. So whatever we give to eval, that will be executed in the current shell. So here we are telling eval this. So 1 second, let me go tell here. So this thing, we are telling eval to execute. So this will also run the same thing. So this is basically now getting this internal thing and it is executing both cal 10 and cal 11 2023. So this eval command will work and the piping the thing to bash will work, but then running it directly inside this dollar bracket or inside backtext, that will not work. So backtext and dollar brackets are like the same thing. So if it works in one, it will also work in the other. But here it will not work in this one because it is having two commands. So it's not working inside dollar bracket. If it was just one command, then it will work inside dollar bracket. We can pipe it.
Here,
Yeah.
so in the third option, uh, here we are giving piping and bash.
Yeah.
If we don't give pipe and bash, then it has printed some cal 10 2023 and cal 11 2023.
Yes.
By which symbol are we getting those in like two different things?
Yeah, so using this braces, right? So using this brace expansion. So in this brace 10, 11, so this is handled by bash, which automatically expands. So we already saw if I do something like 10, 11, so it will print 10 and 11. And then if we have multiple things in it also, right? So if I have again 10, 11, so what this will do is it will expand both and it will do all the combinations of that. So you can see 10, 10 is there, 10, 11 is there, 11, 10 is there, 11, 11 is there. So if I tell this and I give 2023, so here it means space. So this is treating as a separate thing. So it is just expanding this and then printing this. So it's 10, 11, 2023. But if I use the backslash to escape this, so I'm telling the entire thing is just one argument. So then bash will expand 10 and 11 and it will have the 2023 for both. So it will have 10 2023 and 11 2023. So similarly, we can have something on the left side also. So I can say cal this. So if because I have escaped the spaces, so this entire thing is treated as one argument. So now you can see it is splitting into two things. So cal 10 2023 and cal 11 2023.
Okay.
Yeah.
Okay, sir.
Yeah, and in the end, you can add the semicolon by escaping it. So it is the entire thing is splitting into two things. So if we have other things also, so a dot dot c, etc. So you can see it is making that many copies. So cal 10a, cal 10b, cal 10c, and then 11a, 11b, 11c. Right. So this brace expansion is creating these multiple cal commands, and then to run it, we are simply piping it to bash. So this command is being executed in bash.
Okay, sir.
Yeah. Yeah. So that's
So
why
can you
this,
explain fourth options? Why dollar this thing giving correct?
yeah. So fourth and second both will not work. So the second one, if we run, let's see, we ran it earlier. Yeah. So if we run the second one, you can see it is giving bad usage, right? So because we have two things in here, so cal 10 2023, cal 11 2023. So this one cannot run multiple things. So it's giving us this. And obviously, if this is giving us error, so if we nest it inside another dollar bracket, so that will also obviously give us error.
Yes.
Right? So because second one is not working, fourth one is also not working.
Okay.
Yeah. And the
But
first
even
one
can
only
be-
print this. Yeah. Yeah.
Even can work in that case.
Yeah, if it's just one command, so that will work. So you can see if I, let's say, do echo ls. So the output of ls is then executed and stored here.
Yes.
So if I just do this ls, then what will happen is the output of ls is trying to be executed as a command. Right. So here it will say this test2 is trying to be run as a command. So it is like I'm writing test2. So this is not a correct command, right? So similarly, if I am directly executing this, it will try to get this output and run it as a command. But then because we have multiple things, it's not working here. So if we are piping it to bash, then it is reading the entire thing and executing it.
Okay, got it, sir.
Okay, so this one is a bit tricky. So here the question is, we have this file which have this content. So there are stars. So this is basically a rectangle of x's surrounded by a rectangle of stars, and we are asked to print only the rectangle of x's. So given this input, output should be this. So the upper lines should not be printed. The lower lines should not be printed. And in these lines, this left side stars and these right side stars should not be printed. Right. So what we do print is just the x's and the spaces. So here, there are multiple ways of doing this. So one thing is, notice that this is like mirror image of each other, right? So it's reflective. So the left side is same as the right side from the middle. So one way to do this is, let me first create this maybe file somewhere so that we can actually run and see. So let me create this file. So this is basically, sorry, this is like this, and between these we have star and then space and then star. So let me duplicate that a few times, and then afterwards it is basically, so there's a x here. So this one will be, rx. So it's like this. So sorry, yeah. So the first line is like this, where the entire top part of that rectangle is there, and similarly the bottom is there, and in the middle we again have something like, so the star is there, the X is there, and then spaces, and then the X. So let me now duplicate this. So this is the like input, right? So X box inside a star box. So if I get the file, so you can see this is how it is. So now what I want to do, first thing is, if I want to just print the box of X inside, so we don't need the lines where there are no X's at all. So we can simply remove all the lines where there are no X's. So that we can do by using grep. So I can say inverse match, match X. So all the lines where X is there, print that. So these first 4 lines and these last 4 lines, last will not be printed. So only these lines will be printed. So now you can see we have this part. So we now just need to remove this stars on the left and stars on the right. So we can do that using the
Word
cut
break.
command.
We can use
Yeah.
word.
We can use word break. We can also use the cut command. So if you are splitting by the space, right?
Sir, we use the flag -o here because it is already selected. Let's see what happens.
Yes, so here only the X's are selected, right? So if you do this, only the X's will be
Okay.
printed. Yeah.
Right.
So here we want to actually print the spaces also. So here, if I now use the cut, so what I can do is I can cut, and if I use, let's say, like split by the spaces, right? So you can see there's a space between the star and the X. So I can cut by the space. So I can put the space as the delimiter, and I take the second field, right? So this is the space in the middle. So the anything to the left, which is the stars, they are first fields, and everything after that is the second field. So if I just do F2, which is the second field, so I'll just get these X's. But if I do F2 dash, which means second field and all the other fields after second field, so then we will get everything except the first star. So now we can see we have removed the left side stars, only the right side stars are there. So then we can basically do the same thing again by flipping it, right? Because notice that this is symmetric. So what we can do is I can use the rev command. So the rev command reverses each line from left to right into right to left. So now you can see once I reverse this, so now basically this becomes the mirror image of this. So now the left side stars are there, right side stars are gone. So then we can use the same thing which we did earlier. So we use it once to remove one side, then again we use the same thing to remove the other side also. So now you can see all the stars are gone, only the X's are left. So this is one of the solutions for that. So we can do it like this. So first we remove the top and bottom part using grep, and then we remove the left side using this. Then we reverse it and we remove the right side basically using this.
What does
Sir,
Manish do?
here is a extra space before this squares.
Yeah, so it's told right in the question that bounding spaces are not considered, but the proportionality scales and number of characters of the inner rectangle should be the same. So that is fine. So even here you can see that those extra spaces are there in the output. So that is okay. Yeah.
Hello.
So, yeah.
Actually, sorry to interrupt you. Can I get the where can I access the recording, because I have another class and I don't want to miss this.
Yeah, so the recording will be there in this link which I sent here. So this sheet.
Can you share again?
Yeah.
Please?
So the other resources are also there. So this is also pinned in the discourse. So you can use this sheet for the resource. Yeah, sure.
Thanks a lot.
Sir?
Yeah.
Sir, you have given -F2. Then why is it not printing X at the right side, the rightmost column?
It is so
Could
we are
you scroll it above, sir?
Yeah.
Yeah, this one.
Yeah. So because we have given F2, which means only the second field, right? So if I am splitting this thing, so hopefully my mouse is visible, right? So if I'm splitting this thing by space, so these stars are the first field, and then this is the second field, and then so for the first line, then this star is the third field, and for the last line, this star is the third field, And then for the inner lines, these like middle things, there are third, fourth, fifth, sixth, seventh, eighth, etc. field. And then this is maybe, let's say, 11th field. And then this is 12th field. So if I'm printing only the second field, then I'm only getting this X and then this left side X and then all these X's. So I'm not getting this right side X. Right? So that's why we are getting like this C-like structure. So if I'm giving dash F2 dash, which means second and then all the fields after second. So till the end, print all the fields from the second field. So then we are getting both the right side and the stars also.
So I didn't get, so I'm little confused in that.
Okay, so let me run it again. So this is giving us this one, right? So if I get the actual thing, this is like this. So if I'm splitting it with space and I'm printing the first field, then it is this left stars. So this is clear, right? This is the first field.
Yes, sir.
If I'm
Yes, sir.
splitting by space. If I print the second field, then it is this C. So ignore the first and last line. So here you can see this is like this X is the second field, right? So afterwards we have another space, right? So if I'm splitting the line by space, then this is first field, this is second field, then these, like if let's say this was just one space, then this would be third field, this will be fourth field, right? So this is no longer second field. So if I do, let's say dash F3, so you can see it has only spaces. So because there are multiple spaces, each everything between each space is considered a field. So between this space and between the next space, there is nothing. So that is considered field 3. So similarly,
Then,
field 4, yeah.
Then why is the topmost row having all X is printing?
Yes, because here we do not have any space, right? So we just have X everywhere. We don't have any space. So let me print it again once again. So in these lines, you can see the spaces are there. Here we don't have any space, right? So first field, then a space, then the second field, no space. So then a space. So this is then the third field. Whereas in these
It is
lines,
interpreting individually.
yes, this is the first token, then like first field, then space, then second field, then space. So there is like third field inside, fourth field inside, etc. And then finally, this is maybe like 11th field or something. And then this is 13th field.
Okay.
Yeah. So if I do dash F 2 dash, so I'm telling second and then all the other fields afterwards. So then I'm getting everything.
Okay.
Yeah.
Okay, sir. So one more thing, if we give grep asterisk symbol, then the left of the asterisk we don't have any content. And the
Sorry,
first column.
yeah, so if I do grep asterisks, then only the asterisks are matched. Yeah.
Oh no, sir. Sorry. I was telling about the cut thing.
Okay.
Cut, and if we give delimiter as asterisk symbol, then we don't have the content left to it. So if we give F1, then what would that be? Like the
This is
output.
giving empty. Okay, so let me print the main thing. So this is this one. So if I use cut the star, so here we're splitting by stars. So there's nothing on the left of this. So F1 will be empty. But then if we do F2, then here F2 will be this box. Right. So we can also directly cut by star and I can say F2. So this is like one of the other solutions. So instead of doing all that, you can simply split by stars, right? Because there's a star here and there's a star at the end. So we can simply say split by star and give everything that is in the middle. So that is F2.
Okay.
Yeah. So here we don't need to do 2 minus, right? We're just taking the second field.
Okay, sir.
Yeah.
Sir, actually, I can't see the see recording links in that file.
So recording link, because it's currently recording, the link will not be there, right? So after the session is over, then the link
Previous
can
links are also not, I can't see.
Yeah, so TS sessions are generally not recorded. So this one I'm recording because we are discussing PYQs.
Okay. So this this you will be uploading, right?
Yes.
Okay, thanks a lot.
Yeah,
sir,
sure.
Is the yesterday session recorded?
No.
Yes,
So
sir.
TS sessions are not recorded. Instructor sessions are streamed and recorded.
Please upload as soon as possible.
Yeah, sure. Okay, so you can see even the hint of how the rev command works is also given to you. So if you like give any standard input to it, like 1 2 3 1 2, if you pipe it to rev, it will basically reverse each line. So 1 2 3 becomes 3 2 1, 1 2 becomes 2 1. So that is why like this. So as you said, split by star and then F2. That's why this one works. And this reversing way we can also do like this. So we first split by space, then we reverse, then again we split by space, and then so we can do the grep at the end also. We can do it at the start also. So both will be correct. So these two are the correct answers. There is also another correct answer using egrep. So let's see why these will not work. So this first one just tells grep x, right? So as we saw, if we just do grep x, then these left and right side stars also will be there. So that is not a correct answer. And grep vx will obviously not work because this will just print the top and bottom part. So this is even worse than grep x. So this is actually even at least trying to print it, but this will just print the like square of that star. So not even the full square, the different shape. So it will not print any line which had the x, only the top and bottom part is printed. So this is another way of doing it, which is using egrep. So let us see how this is working. So we are getting out the pattern, and this is the whole pattern. And now we are using egrep or grep-e, and we are matching anything that is not a star. Right, so we can say match. So here we are saying anything that is not a star. So we can use the caret symbol, which means invert the matching. So inside the box bracket, if you have the caret symbol, which means invert the matching. So match any symbol which is not a star. So what this will do is this will match so all the spaces and all the x's. Right, so you can see the first line is not printed because there is only stars and no spaces, and the last line also. And the middle lines are still printed because there are spaces, right? So the spaces are matching with this. So the x's are matching, the spaces are matching, the stars are not matching. So if I and we can use the star. So this means not star, the plus. So which means one or more. So this will basically match this. So now if I tell it to print only what is matching and not the entire line. So in so remember that this caret star means anything which is not a star. So in this first line, it is being printed because this part is matching. So except the stars. Similarly, here this part is matching. So if we now ask it to print only the matching part using -o, then we get only the like output. So we get x and then this part. So this will also print the only the internal square and not the external star square. So we can use this way also. So you can see we are using grep does not like all match any character which is not a star, and match one or more of that, and then we only print the matched part. Right, so that's why this is a solution, and then the first two also are solution. So this would be like the simplest solution, split by star and then take the second field. This is like a roundabout way of doing it. So you have to reverse the thing and then do it, and then this is like you can say a more powerful way of doing it using ERE, extended regex. Okay, so let's see the next one. So here the question is, at the end of the execution of the following script, what will be the value of val1? So here we have this script. So echo using all the parameters. So $* means all the parameters of that script. So here we are doing the same thing with $* and $@. So for arg in $* do val1 is arg echo val1. And then again we are doing for arg in $@ do val2 equals this one. So we are asking at the end of the execution, what is the last value of val1? So val1 does not depend on this second part. So only the first part we have to see. So this $* it will basically take all the parameters. So you can see here 11, 22, and 33 are given. So 11 will be there, 22 will be there, 33 will be there, and it's iterating over it. So first 11 will be there, then 22 will be there, then 33 will be there. So the last value should be 33 in this one, but then the answer is 11, 22, 33. Right? So this is because we are using the $* with the quotation marks. So what the quotation marks will do is it will treat the entire thing as one string. So if you use the $* and not the $@, so the $@ treats it as a array, whereas $* treats the entire thing as string. So if we put it in a quotation marks, then the entire string will just be one element. So the loop will actually run just once. So it will not run 3 times, one for 11, one for 22, one for 33, but it will just run once for the entire value 11, 22, 33. So if you don't have these quotation marks, then the answer will be 33. But because we have the quotation marks, because the entire thing is quoted, so it will run once and the answer should be 11 space 22 space 33. So that's how we get this.
Can you explain that echo using again?
Yeah, so here this is just like this will just print this thing. So it will just print echo using $. So this is not shown in the output, but if you are running this, it will print to the screen using $::. So this is not doing anything. So this
Okay,
part
so
is doing it. Yeah.
main thing is we need to understand the for loop.
Yes.
So
Yes.
what will happen? For loop will be run. But my first question is on which file for loop is running?
It's
File.
not running on any file, right? It's using the $. So
So,
if
but
you remember,
what is $* then?
yeah, so $* is all the arguments passed to the command. So here you can see the command runs with 11, 22, 33 arguments passed to it. So $, this was there in week, I think week 5, right? In week 5, and I'm not sure if it was there in week 2, but then yeah, it was there in week 5. So $, $@, these are ways of accessing all the arguments given to a script. So both $* and $@, do that, but then $@ will treat it as an array.
My script.sh contain one line, any line. So if then we will use 4 argument in $, so it will contain the whole line or whole paragraph or what?
It has nothing to do with the file, right? So my script.sh is this script which you're seeing on your screen. So if you are running it with this parameters, right? So you know
Okay,
how.
so 11, 22, 33 you are giving as an input.
Yes, not as an input as stdin, but as a parameter. So while running it, we are giving it just like we give parameters to other commands, right? So just like for grep, we give the pattern and then the file name. So these are the parameters I'm giving to the grep command. So similarly for this script, whatever parameters I'm giving, those will be stored in $.
Okay, and the @ will store this input in a array.
Yes.
So if I will do as for example argument 0, so this will give 11, then next line 22, then next line 33. This is how output will be printed for variable 2.
Yeah, so the val2 will store each one of them one at a time. So it will store 11, then 22, then 33. Whereas this val1, because we are using the quotations here, it will take the entire string. So if you don't use the quotation, the val1 will also go over each of these one by one. So the last value will be 33. But because we are quoting the $* here, that's why the last value is the entire parameters, which is 11, 22, 33. So let us see also. I think it is a bit confusing for some. So yeah, so let me create a script here quickly. And yeah, let us add the bin bash. Okay. So here let us do that. So for arg in $* do, and then we are doing this one, right? So val1 equals $arg. So val1 equals $arg, and then echo $arg, and then done, right? Or echo val1, so same thing, and then done. And similarly, we are doing the same thing with with the $@. So if I remove these quotations from here, so I think this is the same. So this one should be val2, this one should be val2. Yeah, so I'm not printing this thing because obviously it's just a string. So the output should be the same. So here now, after this, if I do echo val1 is val1 and echo val2 is val2. So let me go to the other side. Yeah, so let me run this. So let me first make it executable.
So you can directly run by bash script.sh.
Yeah, that also we can do. So if I run this, you can see if we don't give any arguments, then it'll be empty. But let us give 11, 22, 33. Then you can see, so for 11, 22, 33, it'll directly take the entire thing for val1. So val1 will be 11, 22, 33. Whereas for val2, it will actually have 3 iterations. It will get 11, then 22, then 33, and the last value will be 33. But if I remove this quotations, then even val1 should work correctly. So now you can see both are giving like 11, 22, 33, 11, 22, 33, and both the last values are 33. Right, so if you are quoting this dollar star, then it will treat entire thing as one string itself. So the entire thing 11, 22, 33 will be part of that variable. But if you're quoting this $@ that will not change anything. So the output will still be the same. So let me save this and run it again. Sorry. Yeah. So if you see now the val1, because we have quoted it is 11, 22, 33, but the val2 we have also quoted here, but this is still 11, 22, and 33. So the $@ because it's using an array, even if we are quoting it, and actually we are supposed to be quoting it, so that will work separately. But the val like this one $*, if you're quoting it, will treat it as a one single array, one single string. Right, so that's why the answer to this one is 11, 22, 33. Just give me 1 minute, I'll be back. Yeah. So let's move on to the next one. So here the question is, the following commands are executed in the given order. Enter the duration in number of seconds after which the echo command will be executed. So here we have sleep 1, and then we are running the command sleep 10, and then the output we are running, trying to execute that as a command. And then we are doing sleep 100 and then ampersand, right? So this ampersand means push it to background. So if we are running anything in the background, it will not take our terminal. So it will not stop our terminal. So it will directly go to the next one. So this sleep 100 will actually not do any delay. So this will keep on running in the background, but then, so we'll run sleep 1 first. So the terminal will be paused for 1 second. Then we will do this. So we will run sleep 10 in a subshell and we will try to execute its output. So that also needs to be executed first for us to move on. So this will also take 10 seconds. So 1 plus 10, 11 seconds. And then this will obviously give us some error because we're trying to execute an empty thing, but then it will in total take 11 seconds. And this sleep 100, this will be pushed to the background. So we will not wait for this to complete. So a total of 1 plus 10, 11 seconds are taken before the echo done is there. So the answer should be, 11. Right, so just let me know if this was clear. So even though we are running it inside this command execution, so we will not be running it directly, but then still for its output to be taken, we need to actually wait for that command to be finished. So that's why this will also like wait for that.
Sir, if we use backtick also, is it same thing?
Yeah, same thing, same thing.
So we can use dollar open brackets also, and we can use backticks also.
Yes, both are same. So usually the like dollar open brackets is preferred over backticks because here you can see the opening and closing are different, right? So this is opening bracket, this is closing bracket. Whereas backticks, both the symbols are same. So you can use this, like you can nest one and inside another, right? So you can have multiple like dollar opening bracket something, then dollar opening bracket. So you can nest it. Whereas if you're using backticks, because the opening and closing are the same, so it is difficult to nest. Right? So both work the same way, but then usually this is preferred.
Okay, sir.
Yeah.
Sir, there could be some other variation if that ampersand
Yeah.
moves to the second line at the end of the second line.
Yeah. At the end of the second line. Okay. Yeah. Then I think it should not wait. So the answer should be 1. Let's see. Let's try it out.
Basically, if the subshell runs in the background, then it should not impact our main
Yes,
cell. That is
exactly.
basically.
Exactly. So let me create a script. So let me go to another folder.
But sir, then sleep 100 will run if you use your ampersand for second. Then sleep 100 will run and it will become 101 seconds, right?
Yeah. So we're telling if we have ampersand in both, then it should run for 1 second.
If both, then it should run for 1 second.
Yes, exactly. So let's see. So if we have sleep 1 and then we have this in this bracket, so sleep 10 with ampersand outside, and then if we have, so this obviously will not take time. So let's see now. So if I go to that folder and if I run this, so you can use this. So you can see it is waiting for 1 second. So the total time it took is exactly 1 second. So yeah, this, if you're putting it into background, then it will not matter. So this will also not contribute and this will also not contribute. And okay, let us see what happens if we put this inside here. So I think this should still take 1 second. See?
Should take.
Okay, no. So this is not taking 1 second.
Because what's happening is it's waiting for the. I mean, I don't know. See, it's still waiting, right? Until the control comes back from the subshell to the main cell, it's still waiting.
Yeah. So although it is running in the background of that child shell, but that child shell is active. And the main shell will not move until the child shell is not finished. Yeah, so in total, it still takes 11 seconds. If it's
this is actually the more tricky question, having the ampersand inside the subshell.
Yeah, so thankfully that is not asked. So yeah, so even if it asks now, you should be like able to solve this.
That's the reason why now we are understanding how the dependency works, right? So just looking at that ampersand is doesn't impact our process time. Maybe if it is within the subshell, then we have to wait.
Yes, so the subshell, as long as that is active, even though if it's not in the foreground of that subshell, even if it's in the background of that subshell, as long as it's active, will not move forward. So in here it is 11 in this case. Okay, so the next question is this one. So what is the output of the following? So this I think is just maths, right? So 10 times 10 is 100, and then 5 times 4 is 20. 100 minus 20 is 80. So this is that BODMAS or PEMDAS, so order of operations. So you do multiplications first and then you do subtraction. So you cannot do it from left to right.
So what is the trick here? Just BODMAS rule, that's it?
Yeah, that's it. Nothing else. You also have to know that how this works. So
okay, so it is basically like an expression, right? EXP it's all numeric values. Yeah. Okay.
So here so the order of operations is same as like other languages. So like division and multiplication first, and addition and subtraction after that. So if same operations are there multiple times, you do it left to right. So we do this 100 and this is 20, and then 100 minus 20 is 80.
So only trick.
So in this there is no BODMAS, right?
Yeah, it is BODMAS only, right? So BODMAS means that multiplication and division work in the same level, and then after that addition and subtraction works. And if there are both multiplication and division, then we do it from left to right. And similarly, if there are both addition and subtraction, we do it from left to right.
So first 10 into 10 or first 5 into 4, or both?
So yeah, usually it'll do it like first 10 into 10 and then 5 into 4 and then it'll subtract it. So 100 minus 20.
Okay.
Yeah.
So Badma's rule in other languages, there is
Yeah.
a concept called bracket, right? Because
Yeah.
that's the first thing, right?
Yeah.
But here we have this dollar bracket.
Yeah.
Means the first subshell. Is it running? The first bracket stands for the subshell, right? Or what is it? Or is
No,
just
no,
for
no. So
expression?
single bracket will mean like run something in a subshell, but then double bracket itself is its own syntax, which means mathematically evaluate this.
Okay, it's like an expression basically.
Yeah, yeah.
Okay, okay. All right, thanks.
Yeah. So the next one is this one. So here the question is, based on the information present in the output, how many hard links are present for the parent directory? So basically, you cannot create hard links for directories, but this third column, right? So which states how many hard links there are. So that will tell you the number of hard links for a directory to be basically the number of subfolders it has plus 2. So if a folder has, let's say, 3 folders inside it and maybe 10 files, so the number of hard links for that folder will be 3 plus 2, which is 5. So why 2? Because the dot and dot dot also point to that. So the dot and dot dot, which are 1 plus 1, 2, and then any number of folders which are there inside, that will count as 1. So as many folders there are. So here we are told that this is the ls-li of the current directory. So we need to find how many hard links are present for the parent directory, which is testdir. So we basically just have to count how many directories are here. So here we can see this long listing. We can see this D here, right? So 1, 2, 3, 4, and then these are files, and then again here 1. So total 5 directories here. So 5 plus 2. So 1 for this dot, 1 for this dot dot. So 5 plus 2 is 7. So the answer here should be 7.
So why we're not taking files?
Because in general, files, so the files will not have any dot dot inside it, right? So if you go inside any folder, you will have these two special, right? So you will have the dot and dot dot, which point to the, so dot points to the current and dot dot points to the parent directory, right? So that's why for each folder, it will create a dot dot in that folder, right? So for each folder, we get one more hard link. But files obviously don't.
But if I define, let's say there's a file called this html.txt. If I create a hard link called html_1.txt, so it will have the same inode number.
Yes.
But it can have a hard link. So obviously, by looking at the inode number, I can say that okay, it is a
yeah. So that is for a file, right? So you can create hard links for a file. You cannot create hard links for a directory. So hard links can only organically exist for a directory based on the number of subdirectories it has. So you cannot create hard links on directories.
Correct.
Okay. So we can directly count the number of subdirectories it has, which is 5. So 5 plus 2, we get 7 hard links.
Right. Okay.
Yeah.
Sir?
Yeah.
So if we do ls minus lia, then it will print all the files and directories, including the hidden ones.
Yes.
So the third column of dot and double dot, after executing that command, will be the number of hard links with respect to the current directory and the parent directory. Am I right, sir?
Yes, exactly. So there you can directly read that number and get the answer. But obviously they don't want to give out the answer directly. So they have not done li yet. They've just done li.
Okay.
Yeah.
But sir, factually, there could be actually a hidden directory. Like I think there are some system files are there with starting with a dot. I don't know. Maybe some softwares also could have a hidden directory.
Yeah, they do. So actually, how it began. So I don't want to go into a tangent, but then I'll tell it very quickly. So all folders have this dot and dot dot, right? So dot means current directory and dot dot means parent directory. So whenever you list in a folder, you would always see all these things and then dot and dot dot everywhere. So like the developers of the tools of ls, they thought like, okay, why are we always seeing this? So let us by default hide anything that starts with a dot. So they just wanted to mean dot and dot dot, right? Because both start with a dot. So let us hide anything that starts with a dot and only show it if the user gives us -a flag. So they actually want to see it. But then what side effect of that came is any other file or folder also, right? So if anything starts with a dot, so dot bash rc, etc., those also were not listed with ls. So only if you did ls-a, they were listed. So then people saw that, okay, so this is happening. So what we can do is we can use that to like create files or folders which we don't want the normal user to like always see, but basically like pseudo hidden files and folders, right? So that's why now any hidden folder, they will use a dot, like they'll start with a dot, or any hidden file, they'll start with a dot.
Yeah, makes sense. Thank you.
Yeah. Yeah. So yeah. So here, if we use lia, then we will see that the answer for the dot folders third column, it will be 7. So we can also count like the number of directories +2, and we get 7 for this one. Okay, so here is the next question. So below is a file hierarchy structure provided to answer the question. So here we are telling in the current directory, we have only 3 folders and 1 file. Right? So in the current directory, we have 3 folders named class A, class B, class C, and a file called script.sh. Inside class A, we have a folder called attendance and nothing else. And inside that attendance folder, we have files called feb, jan, and mark.csv. Similarly for class B and class C. So now the question is, given the following script is run, for what value of num will the script output true? So like the script is basically taking 2 arguments, $1 and $2. So $1 we are storing as directory dir, $2 as num. And then we are doing a checking. So we are checking if num equals.
So what is inside $1? One is a variable. Or
$1 is the first argument which we are giving to that script, and $2 is the second argument which we are giving to that.
What does it contain?
So that depends on how we are executing it, right? So if we are running the script with whatever argument we are giving, that will be stored in there. So it is not, it is dynamically decided when we are executing the script.
Okay.
Yeah, so here we are told that, so we are asked for what value of num the answer will be true. So the value of dir, we are told that it will be class A. So assume that this script is run with the first argument to be class A. So what value for the second argument will return true? So what we are doing is we are taking the num and we are seeing if it's equal to the output of executing this thing, which is ls-dir pipe wcl. So ls-dir means list all the files and folders inside a given directory. And so that will print all the files and folders in separate lines. And pipe wcl, so we are giving that output to the input of wc, and wc-l will count how many lines are there. So ls.
So this will give 1 as.
So class A, yeah, so this will give 1, right? So because if we are running ls on the dir, if it's set to class A, so class A just have 1 folder inside here, right? So this will just have 1 line and wc will give 1. So we are basically, the question is find like what is this value? Then we are just told to tell what value should num be there so that the output is true. So that basically means what is the like solution of this value. So yeah, so the solution of this is 1. So if we are lsing this class A, then there is only 1 output in that line, which is attendance. So if we count the number of lines, then we get 1. So the number which we give, if it's 1, then it will echo true. Or it will
don't show the answer. I think we should guess the answer. So here it's a condition. If the condition is true, then you print true, otherwise false, right?
Yeah.
So the condition will be true only when the number is equal to 1, because that's what we just saw, right?
Yeah, exactly.
So that means number is coming in the second argument. That means I should run this script with class A as my first argument and 1 as a second argument, then it will get true.
Yes,
otherwise,
exactly.
Right. So we should guess because sometimes seeing the question we get answers, we get confused, right? So then look at the options.
Yeah, exactly. So here basically this is a convoluted way of asking what is the answer of this thing, ls-dir pipe wc-l. So they have put this in a conditional checking with num, and then if it's true, then echo true, else echo false, and then they're asking what value of num will print true. So that basically logically means what is the answer of this, right? So what is the answer of ls $dir piped to wc-n. So how many files or folders does the class A has? So inside class A, we can see there is just one folder attendance, and everything else it is inside that folder. So we don't count that, only directly inside we have one folder. So the answer for this one is 1.
Modification will be, what will be the, if the dot is the first argument, what should be the second argument to get the true?
Yeah, so if you give dot, then the answer should be 4, right? So class A, class B, class C, and
Yeah,
so
exactly.
okay, so this one, this is a bit long, so let me actually do it here. Okay, so here there's a one small thing which is wrong here. So let us read the question first. So what will be the output of the following command? Cat etc password. So we have already seen what that is. So it's a file that contains user data. So cat etc password, then translate all the colons into comma, then take the first 30 lines, then out of those first 30 lines, take the last 10 lines, then sort k4, 4. So the k means sort not from using the entire line, but using this fourth field. So 4, 4 means, so usually we can give multiple keys. So if I give 4, 3, that means sort first by third field, and then by first by fourth field, and then by third field. So here 4, 4 is basically the same value is given 2 times. So that is same as a dash k4. So just sort by the fourth field. And then we are cutting it using the comma. So remember that we have converted all the colons into comma. So all these will become comma. So cut by the comma and take the third field. So you can see first, second, third. So this 102, 103, etc. That number. So just take those numbers and give me the first row. So essentially, let us now break it down. So here one thing is wrong. So here it is told that. So you don't have to actually do this head and tail. So the output of the head and tail is given to you. So it's telling that the output of cat etc password tr colon comma head 30 tel 10 is given here. But you can see the colon is still there, right? So here this part is wrong. Actually, the output of cat etc password pipe head 30 pipe tel 10 is given to you. So that tr you have to do on top of this. So let me store this in a file so that we can see what will be the output. So I think I do have it somewhere. 1 second. I'm not sure if I have it, but let me see. Okay. Okay, yeah, I do have it. Okay, so I have stored whatever is given here as a file called inp so that we can run this command. Right, so if you see in inp, I have whatever is given here. So this is the output of cat etc password head 30 tel 10. So not the tr. So we already have taken the first 30 lines and the last 10 line of those. So we don't have to worry about that. So first we have to do is we have to translate all the colons into comma. So if we translate all the colons into comma, so basically instead of colons, commas will be here. Then what we are doing is we are sorting by the fourth field. But here, there's one catch here. So if you see the man page of sort, so the dash k, let me scroll down here. So the dash k, which means the so
But that's
sort.
the problem. In quiz, we can't use man page.
Yeah, right. So you have to know the few like popular flags of the few commands, right? So if everyone knows everything, then everyone will get 100, right? So few questions will be there to test if someone knows the few of the popular flags, whereas some others don't. Right, so you have to know the few commands, things like sort, unique, cut, etc. So things like D, F, and then A, and then another thing is there T. So those things you should know because they are taught in the lectures. So sort, cut, find, unique, all these commands are there in the lectures.
In week 4, sir?
No, it's not in week 4. It's there in the some command line utilities lecture.
Which week? Because
I have to check that. So they're there in the lecture titled "Some Command Line Utilities." I'm not sure in which week they are. I'll have to check and get back to you. But then yeah, so the sort, if you see the dash k flag, so what it does is it will sort via a key. So if you tell it to sort via the first column or the second column or the third column, then it will sort via only that column. But here you have to understand that sort internally will obviously not know what is a column, right? So it will not know whether a line is split by colon or by comma or whatever. So for dash k to work, we also have to give the dash t flag, where we actually mention what is the field separator. So if I don't tell sort that the field separator is comma or the field separator is colon, then sort can actually not even use the dash k. So here first of all, the dash k 4,4 basically simplifies to dash k 4, but then because we have not given the dash t, this simplifies to just sort. So we are just doing a simple sorting on this. So if we have this file and if we just sort on this, so it will just do it alphabetically using the from the entire line. So from the first of the line, it will see what is coming first. So like the underscore will come at the top, then A, then B, then C. So if you see, if we sort this, so now the output is like this. So underscore, then D, L, M, P, S, and then U. So it's sorted alphabetically. And
so in the question, I mean, maybe they wanted the students to sort it by the fourth field, but maybe the mistake. Right?
No. So this is basically given as a a thing to throw you off, right? So if you know this and if you know what dash k does, but you don't know it completely, if you don't know that you also need to use the dash t, then you will sort it by the fourth column, right? So here you can see the fourth column. If you sort, so there are actually now two things. So okay, let me show it one by one. So we have this input, right? So let us first do the PR. So we translate all the colons into commas. So now this is the output. So now on this,
Translate is similar to replace.
yes, it is the same thing. Yeah. So this will only replace one character with one character. So after I have replaced all the colons with commas, so now let us do this sort k44. So you can see if I do sort dash k4,4, so you can see the output is same as the normal sort, right? So it is just sorting alphabetically. So what will happen is if someone thinks that, okay, we should sort using the fourth column because we have given 4,4, so then they will get it wrong. But then there are also two ways of getting it wrong. So you may think that, so let us see. So if we give the actual thing, which is dash t and then comma. So I'm telling sort that split the lines with commas and then take the fourth field and sort by the fourth field. So now you can see the output is different. So you can see 1 is coming at the first, but then you can see the next is 1,000, right? So 1, 1,000, 106, 103, 110, 108. So it's not sorted numerically, but it's sorted alphabetically. So as 1 comes before 6, so all the ones are before that, and then all the 6,000s are there. So so it will not see that 1,000 is bigger than 106 because it's sorting alphabetically. So because 100 comes before 106, so that's why it is sorted like this. So if you then wanted to sort it numerically also, you also had to give the dash n flag, which means sort as a number. So then you can see the output will be like 1, then 106, 107, 110, 112,000, then 65,000, etc. So there are multiple ways of getting it wrong. So you might be thinking that it's sorted with the fourth column numerically, which is not true because we have not given the dash n. You may think we have sorted it with the fourth column alphabetically, which is also not true because we have not given the dash t. So it does not know what is the fourth column. So what it actually does is just sort using the entire line alphabetically. So it just uses the first part only. It can identify which comes before which. So it's sorted like this alphabetically. So the rest of the question is pretty simple. Yeah.
Sir, in the output, the first line is 1, and the second one is 1,000, and then the next one is 106, 103. How does it interpret? Sir, could you please explain it once?
Yeah, so we went over that, right? So if you sort it numerically with a dash n, then it will do correctly. So you can see 1, then 106, 107, 110, right? So it's correctly in the numerical sorted.
Okay, sir.
If
This
you
one
don't
is
use -n, then this will sort it alphabetically, right? So if you're sorting with the fourth column alphabetically, 1 comma comes before 1 0, like the comma in ASCII comes before 0. So 1 is at top. Then here 1 0 0 comes before 1 0 6. So 0 comes before 6, right? So that's why 1000 is before 106. So it's the same as how dictionary sorting works. So if you sort 1000 and 106, so it does not care if it's 1000 or a million or like a crore. So because it is 100 and this is 106, so 0 comes before 6, so this is before this. So this is sorting alphabetically. Yeah. But then neither of this matters to us because we have not given the -t comma in the question. Right, so this will just sort it like this. So if you just do K4, 4, this will just sort it alphabetically along, like using the first column itself. So here you can see like it's pretty simple, right? So D comes before L and etc. So here one thing which might throw you off is whether the underscore will be at the first or at the end. Right? So if you're sorting letters, whether underscore comes before A or if it comes after Z. So yeah, in ASCII underscore comes before A, right? So that's why this line will be the first line, and then like the everything else is pretty simple. So you take the like you split by comma, take the third field, and you take the first line. So this is the first line, and the third field is 104. So that's why the answer is 104 here. Right. So like this part basically means take the first line's third field. So the most thing to think about is how the sorting will work. So if you sort it alphabetically with the like the first column, then it will get the correct answer. If you sort it alphabetically with fourth column, you will get a different answer. If you sort it numerically with fourth column, you will get a different answer, etc. So here
three distractions in this question. One is first of all this head -30, tail -10. If we are giving the output, that's a distraction, right? Unnecessary.
No, so you need this, right? Because you don't know what is there in this etc password file. So like in the exam, you cannot think what is there in etc
They
password.
could have given, let's say this is the entire file, and they could have done head head minus whatever, like a subset, and then also instead of 30 and 10, they could have done a small number. That's also possible. But I guess
yeah, so basically they're telling that this entire so what they could have done is they're told this is the file, and on that run this thing, so sort, cut, and head. But what they've told is this entire thing. So you have to understand that because they've already given you output of head 30, tail 10, so you don't have to do head 30, tail 10 on this, right? So even if you do, it will not do anything because this is already just 10 lines. So head 30 of this will still give this, tail 10 of this.
Actually.
Yeah, it'll not matter. So we have already done head 30, tail 10 of the entire file and got this. So one thing wrong here is they have written tr as in this. So this is actually not output of doing tr. So tr you have to do after this. So on this you have to do the tr. Yeah.
Otherwise, there should be comma in this output.
Yeah, exactly.
Yeah. Okay. Thanks for explanation. I think this is very helpful.
Yeah. So, but like even if but in the end it does not matter for the sorting. But then yeah, for the cutting it will mess up, right? So if we are just doing this sort, cut, head, then the cut will not work if it's colon. So yeah, we have to do the tr ourselves, and then we have to sort it and take the first line's third field. So because the underscore is like at the top, so we'll get 104. Okay,
essentially, it's finding what is the group number of the user with whatever, like some kind of, what does it mean essentially?
Yes, no, I think the first column is like the third column is user ID and the fourth is group ID. I'm not sure, but then yeah, so that thing.
Yeah.
Okay, so let's move on to the next. Okay, there's no next one. Okay, so we have taken 2 hours to do this one PDF. So should we go on to another PDF? Hopefully it will not take us again 2 hours because some questions hopefully may be similar, but then I'm not willing to go till 11 p.m. But then yeah, let's see some questions of another week also, another term also. Okay, so here the question is, excuse me. So we have made a directory MIDIR, and we have created a file inside MIDIR called file1, and we have created
In,
another.
in this term, we can see similar pattern because I saw last 3 terms paper. There was no pattern, sir.
I didn't get you. Like,
So
what pattern?
if you take any other subject,
Yeah.
you will see some of the patterns.
Okay.
Like
Similar questions.
Yeah, similar question. Not exact similar, but yes, if let's say it's a BFS question, you will get BFS question, but different graph, different things.
Got it. Yeah.
If you see in system command, there is no pattern, sir.
Yeah. Yeah. Like in general, I think these instructors like create questions every term, like new questions.
How to do this, sir?
Yeah. So like you have to learn the actual concepts, right? So you cannot like just prepare the PYQ. So the PYQs will tell you how much prepared you are, but then the preparation you have to do with the actual content and studying all the things that are there in the first 5 weeks. So this is a way of evaluating yourself, but then not preparing. So the PYQs will not just like prepare you for the quiz, but will test how much you are prepared. Okay, so yeah, so here we are creating a folder MIDER, and we are creating 2 files, file1 and file2 inside MIDER. Then we are making a folder subder inside MIDER, and we are creating a file3 inside that subder. And then we are trying to remove this subder, which will obviously fail because the folder is not empty.
Because file3.txt exists in it.
Yes, because there's a file in there, so it will not let us do. So select the output of the our script, remove directory subder, no. Remove directory dir and subder, no. Remove files from subder, no. Exit with exit code not 0. Yeah, so basically it will not work. So it will give you a non-zero exit code. So if you try to delete a folder which has some...
Actually, it is displaying error, sir. I have done it.
Yeah, so same thing, right? So if you're displaying error, that means it is exiting with a non-zero exit code.
Yeah.
Yeah.
Yes.
Yeah. So it'll like give you an warning. So it'll give you an error that you're trying to delete a folder, but that folder is not
Which
empty.
is not empty.
Yes. So because we have this file3 in there. So because it will throw an error and it'll not do it. So it'll also exit with an exit code, which is non-zero.
The corollary to this question, right? Instead of asking this, you say the answer gives an exit code 0. In order to remove the error message, what should be the command?
Yeah. Then you can use like rm
rm minus rf.
Yeah, that will remove the folder and everything inside. Okay,
So that is using rmdir with minus or option, sir?
No, you don't need rmdir. You use the rm command, rm-r. Yeah, r means recursive, so it will recursively delete everything inside it.
Okay, directories also, sir?
Yes.
Okay.
So this is a script, and then we are asked what will be the value of var 42 at the end of the execution. Use the following information. What information is there? Okay, so how disown works is told. Okay, so here we are exporting a variable myvar sunset, and then we are creating a small letter myvar equals sunrise. Then we are doing echo var 11 is myvar, var 12 is myvar. So both of these will work. So var 11 is sunset, var 12 is sunrise. Then we are creating a subshell. So inside a subshell, only the exported thing will be available. The not exported thing will not be available. So here we are doing, again, we are doing myvar is sun underscore rise and my underscore capital var underscore small var equals sunset. Then echo this. So we don't care about these. We care about the var 42. So we are setting the myvar here, and then we are setting myvar here to be sunset, and then we are disowning this. So we are running this in the background, and we are not tying it to a terminal. And in the end, so the var 42 will store the value of my underscore var, so which is defined here. So because everything else is done inside the subshells, so whatever it is done inside will actually not affect the parent subshell. So we don't even have to see what is done inside, whether it is disown or wait or whatever. So in here, whatever we are doing, it will use their own local variable. So the outside the myvar will remain unchanged. So it will still be sunrise. So the answer for this one should be sunrise. So yeah, I can see the answer should be sunrise. So
Sir, if we did the export inside the subshell,
no, so export only means that so my current shell and my child shell can get it, but the parent shell's variable you cannot change.
no, I know, but let's say, oh, okay, I see. So, okay, got it.
Yeah. So basically,
So
like a security
here,
feature, right? Yeah. Yeah.
sir, here we are running the sun underscore rise sun underscore set uh, in the subshell, and
Yes.
in that we are running something else which is in that, and
Yeah.
after that we are giving and disown.
Yes.
Like, what does that mean?
Yeah, so you can see the disown here. So what it does is basically it will remove jobs from the current shell. So if you are so here you can see we have this ampersand, right? So this entire thing is run in the background. So because this entire thing is run in the background, but it is still stored as the job of that shell. But if I type this disown command, so the disown will remove the last run job from the terminal. So it will run, but it will no longer be owned by that terminal. So it will have its own process ID. So you can like read more about it like in here or like the actual man page of this one.
Okay.
Yeah.
Again, these
So
are all distractions, right?
yeah, yeah. But then these are actually not required for this question because here
Yeah,
you can
but
see.
that's what, so that is the pattern also we see, right?
Yeah.
So when you know that a subcell is background and disowned, then you don't need to read anything, right? So
Yeah. So it doesn't even matter if it's disowned or not. So because the
but
child shell anyway cannot change the value of the parent shell.
because
So
the export is the capital one, not the small one, right?
yes.
So yeah, and then there is a technical mistake here also, right? There is no variable called var42. See, there's an echo command.
No, no.
That
So here it is telling what will be the value of var42 as in like what is this output? Var42 is colon, then this one.
yeah, but technically it is there is no variable called var42, right? It is basically the question should be what will be the output of the line number, whatever they are given, then that is technically correct. But there is no variable
Yeah,
called var42.
yeah, yeah. So like technically they did not tell that it is a
Yeah,
variable. So the name
right.
is var42. Yeah, but then yeah, I
Right.
get your point. Yeah.
Yeah.
So what is the output of this line?
So,
So
and any command given in the subshell runs in a background.
no. So by default it will run in the foreground only. If you give this ampersand, then it will run in the background.
Okay. Okay.
Yeah. Okay, so let's move on to the next one. So here we have identified the correct pair for the output of each command. So here we have this date. So if we run date simply, we get this output. And then what we are doing is we are running the date, as you can see, is in the dollar brackets, and we are taking its output and we are storing it as an array. So this creates an array, and each space separated field becomes an element. Right. So this mon is the first element, June is second element, 12 is third element, etc. So this is an array now. So what happens when we do echo date disp, then echo date disp bracket 5, and then doing it correctly using brace and then using this :1:8. So if we just print the value of a variable, which is an array, it will just print the first element of it. It will not print the entire array. So the first one should be mon. And then the second one we are basically doing, so this is not a way of indexing array. Right, so we are just doing the variable, which is mon, and then 5. So I think this one should be like mon 5 or something like that, or it might be an error. Uh, so this will not actually get the fifth element. So this is the way of getting the fifth element. So the third line. So that will get the 0, 1, 2, 3, 4, 5. So this will get you the 2023. And this one, so that's 1:8. So here you are getting it will give you the on the, I think so. The on is coming from this mon, and then the d is coming from this d, which is actually their part of this. So again, as we saw in the first one, so if I just write date this will give me just the first element, and then I am taking from the index 1 to 8 lengths, but obviously there are not that many characters, so it will just take till the end. So from the index 1 to the end, it is on. So on and then the. So the 4 will be this one A, so 4A, 1D, and then the 3 will be this one C, and then 2B. You can see 1D, so this one will D, 2C, so this one will give this one. This 3 will give me B, so mon 5, and then 4 will be A on the.
So indexing always starts from 0 only, no, sir?
Yes, yes, it starts from 0. So that's why this 5 is giving us 2023. So it's 0, 1, 2, 3, 4, 5.
I think that was the trick. The second echo is the trick one without the
Yeah.
curly bracket.
Yeah, yeah. So you may think this will give you 2025, but then this will give you mon and then 2025. So this M should be capital here. It should not be small. Yeah.
So in the fourth command,
Yeah.
date underscore this :1:8. So like how is it working?
Yes. So the first one you understood, right? So if you just give the variable name,
Yes, sir.
the first element of the array is given. So this also gives mon. So we have got mon here. So now this is the like variable taking like parts of the string of a variable, right, which we saw in week 2. So if I'm taking mon and I'm taking from the like index 1 and I'm taking 8 characters. So index 0
the
is M.
offset thing.
Yes. Yes. So it is offsetting. So it's taking from O and then taking 8 characters. But obviously there are not 8 characters in here, only 2. So it's taking OM. And then this
So here it skips first character, and from there it will printing 8 characters. But here we don't have the 8 characters, so it's just printing right after to the skipping the first character.
Yes.
Okay, sir.
Yes.
This itself can be a question. If you give that, you give an option on, then you can do to confuse on, then a space, then a June, then it will fall for the trap.
Mm-hmm.
Yeah.
Exactly.
Yeah, my God. Okay.
Yeah. So the next one is following lines.
Can you tell me? Excuse me.
Yeah.
I got confused with 2000. Second option is 2023. How come it is 2023? Can you explain me one more time?
Yeah. So second option is basically the third line here. So the ordering is different. So second option means the third line. So here, this is the correct way of indexing a array, right, in Bash.
Okay.
So here, this is a array, and this is like all the spaces separate each element of the array. So mon is the first element, June is second element, 12 is third element, this time is fourth element, this is fifth element, and this is sixth element. Right. So 5 means 0, 1, 2, 3, 4, 5. So the sixth element will get.
Okay. It starts from 0. Okay.
Yes. Okay. So next one, following lines are a part of shell script for job submission to a server. Assume that previous job ID stores 1234556.previous value and home stores user value. What will be the value of PEMDAS variable? So PEMDAS variable. So TPDIR is we are executing something and storing its output as this TPDIR variable. So echo PBS job ID. So we know PBS job ID stores 123456.pbs. So this will basically be 123456.pbs. So then we cut with the dot, right? So D dot means split this by dot and get the first field. So obviously if I split this by dot and get the first field, I will get 123456. So TPDIR variable stores 123456. Then tempdir is home/scratch/job and then TPDIR. So this will be home. So whatever is the value of home. So here you can see value of home is /user. So this will be /user/scratch/job 123456. And so we are asked what is the value of tempdir. So that is this one, user scratch job 123456.
So this is a good question because in real life, when you are running this machine learning jobs or whatever, right? So job IDs get created, and you want to keep the job log, right? This is a wonderful way of you keep it.
Yes, exactly.
Real life question.
Yeah. So this one I think is simpler than the other ones, right? So almost everything is told already. So like previous job ID, you just split it by dot, take the first part, and then you put it at the end of this. So this is basically like take it from the question, put it in the question, you get the answer. Okay, so next one, okay, regex. So this will easily take us maybe 10 minutes. Okay. So choose the most appropriate regex to match a email address. right? So these are given in ERE or extended regex. So things like plus, question mark, etc. We don't have to escape them. So let us see all the options. So here, what we are telling is, email has a few parts, right? So email will have the @ sign. It'll have something to the left of it. Then it'll have a domain, which can have like anything, but then it should end with a dot and then some like something like com or something like that, right? So it can be anything. So a dot should be there, at least one dot, and then this @ should be there, and then there should be something here. So here, this is basically what we are doing. So this part is checking for things present on the left, and then the @ is the literal @. Then this part is things on the right, and then this dot is supposed to be this dot. But then here you can see we have directly given a dot, right? So a dot in regex matches any character. So if I want to match the literal dot, which should be there, then we have to escape the dot. So that's why this one is incorrect. So the next one you can see we have escaped the dot, right? So we have to take like, it can be any symbol. So here we are checking that like the left side of @ it can only have A to Z capital, A to Z small, 0 to 9, and then a few symbols like dot, underscore, percentage, plus, minus, etc. And those have to be present one or more times. So we have this plus, which means one or more times. So then this left side can be anything. And then we have to match @ sign. So after the @ sign, again, we have a few characters. So here we are allowing less characters, A to Z, 0 to 9, dot and dash. And this also we are having plus. So it can be any number of characters. And then this dot here we are matching correctly with a backslash. So backslash dot means actually match the literal dot. And then we are matching the last part, which is this .com or .in, etc. So here we are telling that it can only be A to Z or A to Z, right? So it cannot be something like .co2, right? It can only be something like .com, .in, etc. So it can only be letters. It's A to Z, A to Z, and 2 comma. It means so minimum match 2 letters, but maximum it can be any letter. So the domain can end with anything, right? So there is even a pizza domain. So the domain can have any number of letters, but then minimum is 2. So it cannot have a single letter. And then obviously we are matching the word boundaries on the left and right. So we want to see, okay, maybe the entire email we matched correctly, but if there was some gibberish on the left or right, then that should not be considered as a valid email. So only if that is the entire word, then we match the email. So the difference between that and the next one, you can see. So let's see what is the difference. So this one obviously does not have the word boundary, but other than that, yeah, you can see that the @ we have the star. So we are telling there can be 0 @, there can be 1 @, there can be multiple @. But obviously that is not true. All emails can have exactly 1 @. So this one is wrong. And in the fourth one, it is basically same as this correct one, second one, but here we have star instead of plus. So we are telling the things to the left of the @ can be present 0 times also. But then we know our email address have to be at least of 1 character, right? It cannot be 0 character. So that's why the star will not work. It has to be plus. So that's why this regex matches and the other ones don't match.
So this is ERE, but if it was the normal one, then it will be even more complex with the backslash.
Yeah, like you have to understand, like there will be like more characters, like all the pluses and all will be escaped. But then this dot will not be escaped.
But the
No,
dot
no,
will escape, right?
dot will still be escaped. Yeah. So
Yeah,
in
yeah.
ERE, BRE, both the dot has to be escaped.
Dot, yes, correct.
Yeah, but then like this brackets, right? So this also will have to be escaped in BRE.
Yeah, more messy. Yeah.
Okay. Yeah. So hopefully this one is clear. So like there is no correct regex to match an email address because the specification of email is itself very complicated. So even like big companies like Google and all, they actually cannot validate all the correct email address according to the spec. But then here you just have to choose among the 4 options, and out of these 4, 3 are definitely wrong. One is partially, like it will work most of the time. So obviously this is the correct answer here. Okay, so let's go to the next one. So I'll do this till 9:30. So we'll not do the other PDFs. So feel free to go through the other PDFs also. So prepare as much as you can. So this question is based on the TR. So the help page of the man page of TR is shown here. So the question states, okay, this is also man page. Where is the question? Okay. Using the above content, choose the command that deletes all occurrences of A. Okay, so A from what? What is the question? Okay, so this is how TR works. Let me, yeah, and yeah, this is also part of the TR main page. This is also part. Okay, so okay, so the question is not stating it, but then in the options you can see. So there's a file called my file, and in that file we have to choose a command that deletes all occurrences of A from that. Okay, so we have a few options. We have cat my file, tra space, right? So translate or replace all the A's with space. So here also it's clarified that there is a space between the quotes. So obviously if you are substituting A with a space, then it is not the same as deleting a A, right? So instead of A, you now have a space. So which is not the same as deleting the A. So in the second one, it is replacing all the spaces with A, which is also totally wrong. So the third one is correct. So we use the -d flag to delete something. So we can use tr to substitute something with something, but we can also use tr to delete something. So if we give the -d flag, then it just takes one parameter, which is a letter to delete. So in the entire file, it will delete all the occurrences of A. And fourth one, obviously not correct because we are escaping the A, which means a special character, whereas we just want to delete the A symbol. So here the third option is correct. Do we have a fifth option?
Sir,
No.
the
Yeah.
first option replaces A with space.
Yes. Yes.
Okay. But that is also a sort of like deleting A.
Yeah, but then instead of like it is not just removing the A, it is putting a space instead of that A. Right. Whereas we are
Okay.
asked to just delete the A. So this will just delete the A, whereas this will instead of A
Okay.
put a space there.
Okay, okay, sir.
Yeah. Okay, so next question is the following script takes list of file names as inputs and find if a file is what if we put star only? What do you mean without space? Oh, that is not a star. Sorry, my screen is small. Okay, you are telling that inverted comma. Yeah, let's try that. I'm not actually sure if that will work. Okay, so I already have.
That's like a null character, right? So,
yeah, so here let's say I want to delete the colons here, right? So if I use tr-d colon, then this will obviously delete that, so it will be gone. And if I use tr colon and then space, so this will delete that, but then there will be a space. And if you give an empty thing, then yeah, you can see that tr does not allow that. So it will say when truncating set1, string2 must be non-empty. So you can either use -d to delete something, or you can use two parameters to substitute, but then the second parameter cannot be empty. Yeah, so yeah, try these out so that you know how the command works, right? So even in these edge cases.
so we can use a grep command also. Cat this grep a and then replace. Like that is also possible.
Yeah, so if we do this, then it will just print all the lines that have A. Yeah, what we can do is we can say -v A and then -o. So
Yes.
no, this will also not work because it will print each character in a separate line. So instead of this, what we should do is basically put this as regex maybe, and then not A, and then plus. So maybe this will work. But then why is it not working? Okay. Yeah, sorry. We don't need the V anymore. Yeah, so this should work, but then it'll still split it. So yeah, we cannot use this to get the entire line. So the easiest way to do it is using the tr command.
TR command, yeah.
Yeah, that will just
inside VI editor, we can do that global replace /a.
Yeah, that is obviously there. You can do it in VI and Emacs.
Correct.
Yeah.
Let's continue.
Yeah. So by the way, the previous PDF did not have any question on VI or Emacs. So, but then that does not mean that this term also it won't be there. So some terms it is there, sometimes it is not there. But then if it is there, then the questions will be on both VI and Emacs. So you can just learn any one. You don't have to learn both.
Someone just said, right, let's not go with any because we have to be ready with anything because
yeah,
it will be a totally new question.
Okay, so this one is foreign script takes list of file names as inputs and find if file is executable and counts the list and list out executable files. So identify the missing block from the following. So here what you can see, we have a array called files that is just storing basically whatever we have given as parameters. And we have an array called executable files, which is empty. And something we have to do in between, after which the executable files array should contain only those files out of the files array which are executable. So then this part is automated. So we are basically printing the number of things. So if you remember, hash means number of items in the array. And then we are printing all the things. So we just have to do this thing. So read every element of the files array. And if it is executable, put it into the executable files array. So
But
this we can.
the question doesn't ask whether the user or the group or others can execute, right? Because it's not clear.
So if it is not told, assume that the user. Yeah.
Okay.
Yeah. So here what you have to do is you have to use the test command. So in the test command, you can check if something is executable. So if you go down here, you can see we have the -r for checking if a file is readable, -w to check if a file is writable, and -x to check if a file has execute access. So this -x we will be using. So we will go over each element of file. So we will run a for loop. So for file in files, if test-x file, then we will append it to this array. So executable files plus equals that file. You can see that is the correct answer. So this tick one. So the first one is that. So we go over all the files. So for file in files, then we run a loop. So if executable, so we can use the box bracket or we can use the test command. So if -x file, then executable file plus equals the file. So we are appending this into the array. So the second one is obviously wrong because instead of iterating over the values of that array, we are iterating over the length. So obviously we cannot iterate. So the hash will just give me the indices. So each value of file will just be like 0, 1, 2, 3, 4, etc. So it's iterating over the indices of that array. And the third one, so this is similar as the first one, but then here instead of doing executable files plus equals this, we are doing executable files equals this array plus 1, which makes no sense. So we are adding 1 to an array. And then the fourth one is similar, but then here instead of using -x to check if a file is executable, we are using -f. So obviously this is also not correct because we don't want to check if a file is present. So you want to see if it is executable. So you can also even if you don't know how it is done, you can actually see the pattern. So you can see the first line for 3 of them has add and only 1 has hash. So this is obviously odd one out. And then the third line, this has -x, this has -x, this has -x, and this has -f. So again, this is odd one out. And again here, this is plus equals, this is plus equals, this is plus equals, and this is equals. So again, this is odd one out. So the only one which matches everything is this one, right? So hopefully you know how it works, but even if you don't, sometimes you can see these patterns and understand.
I think it's an important skill, sir.
Exactly. So, if you don't have the skill of understanding, at least you should have the skill of guessing, like smart guessing, right?
So
Yeah.
the dollar at inside the double quotes means it'll take it as separate arguments.
Yes. So all the arguments that are given to that script, it is taken as an array. So each argument, one by one, they will be taken as elements of that array.
Okay.
Okay. So let's go to the next one. So here the question is, which of the following commands will generate output for both test.out and test.err files? Assume that exec is not a command and will generate an error message. Okay, so here you can see we have commands echo test and exec. So it's told that exec will generate an error. So in all the options we have this and exec. So this will always generate an error. So what we are doing is we want to generate output for both test.out and test.err. So we are printing test and we are running a command which does not exist. So this test will be given to the standard error because we are running it together. So if you see, if we are putting so this test, the test will be given to the standard output, and this EHC not present as a command will come to the standard error. So now if I redirect the error to the test.err, then obviously this error part of that EHC not being present will be stored in test.err. And then I can directly do greater than test.out. So that will redirect it to the test.out. But we can also use the T command. So the T command basically takes a standard input and prints it to both the terminal and to a file. So here we are basically using the T command and then redirecting it to test.out. So this will also have the same effect. So this has given to basically confuse people, but then this will also work. So even if you don't have this pipe T, this will still work. So the
can I on the second option, instead of piping with a T, can I write one greater than test.out?
Yeah, you can give one greater than test.out. You can also omit the one. You can just say greater than test.out.
Right, exactly. Yeah. Only thing is I will not see anything on the screen. Screen will be empty.
Yeah. So
without giving one and redirecting it to test.out will also work, na sir?
Yes, that will also.
Okay.
Yeah. So here the other ones will not work because here we are redirecting standard error to the standard normal output. So here what we are doing is both the errors and the normal output will come to the standard output, which is given to the test.err. And then T will not get anything at all because we are not, there is no more output given. So that T input will itself be empty. So test.out will not be created. And then similarly for this one, so doesn't matter how we are running the T itself is not getting anything. So this one will also not work. So we cannot use the 2 greater than and 1 here, which the first, third, and the fourth one does. Only the second one is correct.
So here 2 greater than ampersand and 1 means redirecting error and output to.
No, so 2 greater than ampersand 1 means redirecting the standard error into standard output. And here we have 1 greater than test.err. So that means redirect the standard output to test.err. So both will be redirected to test.err.
Okay.
Yeah. Okay. So this is the next one. So I'll not do it after 9:30 because I'm already starting to lose my voice.
Yes, sir, no problem. We'll stop at 9:30.
Yeah. Okay. So select the regex to extract only the value of email from the below JSON file named as test.json. So here you can see we have this is basically JSON, right? So if you're familiar with MAD1, MAD2, so it's a list and then there are objects inside, and then each object has a email attribute. So similar to list and dicts of Python, but a little different. So we have to just extract the emails. So this is similar to how we did in the previous year's email matching. So here it's also telling you can use the -o to only print the patterns that is matching. So here also what we can do is first we can obviously get only the lines that have the word email, right? So here out of all this, only this line, and this line will be printed. So we have already extracted the lines that have just the email. Then we can simply split by this quotations, right? So if I split by quotation, anything to the left of this is field 1, this email is field 2, this colon is field 3, this email ID is field 4, and this comma is field 5. So I want the field 4. So we grab the email line and then we cut by quotations and we take the 4th field. So this is one of the correct way of doing this. Another way of doing this is we can use the extended regex. Right? So what this is doing is basically it is matching for the single quotation is the pattern. So the entire pattern is inside single quotation. So we can put double quotations inside. So this will match the double quotation symbol. So I'm telling match double quotation email, double quotation, colon, space, double quotation, and then this one, which is anything which is not quotation, right? So anything which is not a quotation in between these quotations. So this is basically this email part, and then a quotation. So this entire line will be matched here. and then that I am cutting by the quotation marks. So same as the first one. So once I've gotten this part, I can split by the quotation marks and I can get the fourth field. So that will give me the email. So the other two, if you can see here, so we are grepping email as the first one. So this will still work. But then here we are splitting by space and taking the second field. So if we split by space, so this part is the first field and this part is the second field. It will also contain the quotation marks and the comma, but we don't want that. So that's why this third one will not work. And the fourth one will not match anything at all because we are matching email colon, which is not part of the line, right? So we have quotation, email, quotation, colon. So fourth one will not match anything. Third one will match the lines correctly, but the cut will not work correctly. And the first and second one will both match the line correctly and cut the line correctly.
So in the option 2,
Yeah.
we are giving double quotes outside the square brackets, which itself gets matched to the the email part. Then why are we using the negation double quote inside the square brackets?
Yes. So what this means is this entire thing is the pattern. Okay, like the single quotes, the starting single quotes and ending single quotes means this entire thing is the pattern. So I'm telling match quotation, email, quotation, colon. So that will match this part.
Okay.
Then I'm telling
Okay.
match another quotation, which is this starting quotation. Then I'm telling match any character which is not a quotation for as much as possible. So which will match this entire email, right? Because none of these characters are quotation marks. Then again I'm telling match a quotation. So it will again match this ending quotation.
Without giving quotation after to the negation symbol will also work, no sir?
Sorry?
Here we don't have any quotation inside the email part,
Yes.
but instead but still we are giving it after to the negation.
No. So
Why?
this is required because see, first of all, like the email cannot have a quotation inside because quotation is used to enclose the field, right? So it will always be quotation open, the value of email, and then quotation close. So this is matching. This first part is matching this email. Then this quotation is matching this quotation. Then I wanted to match any character as much as possible till before this quotation, right? So I cannot say just character like letter A to Z because there is a dot also, there is a at also, right? So that's why we are using this bracket negation quotation. It's telling any character except a quotation marks I'm matching as much as possible. So it's matching all this and email ID till the M. So this quotation will not match that, right? So it's matching till here.
We can also give dot star.
Yes, so we can use dot star also. Yes, so that will work because usually like it is formatted correctly, so there's no email here. Yeah, but yeah, so this will also work. So this is basically any character except quotation, and dot will mean any character. So we match the entire email and then we match the ending quotation using this double quotation.
Okay, sir.
Yeah. So like this is basically overkill. So you can directly do the first one. So just get a line which has email and then split it. But then this will like also work. So it's not wrong. Okay, so here we have to like do this and actually match the actual email because we're using the -o, right? So if we used grep -o email, then it won't work because if you're using -o here, it will just print the word email in the line. Because we are using grep email, then it is getting the entire line. That's why we can cut it. So similarly, because we are using grep -o, that's why we have to actually match the email also. So that's why we are doing this and getting the email. So here we can use dot plus also, that will also work. So we are basically matching not just the word email, but also the email. And then we are cutting and getting the email part. Right, okay. So what is the next question? Following file contains the information on websites visited on a certain server. From the options, identify the correct regular expression which can capture the website domains. So something like this. So HTTPS this or HTTP this. So it can either be HTTPS or HTTP. So it will be like this. So we have to basically write a regex to match HTTP or HTTPS something. So we just have to write the ERE, not the entire command. So you can see the first one. So the second one and third one is pretty simple. So we are telling HTTP and then dot star. So dot star basically means that HTTP and then anything is there after HTTP. And then we have the double forward slashes, right? So it can be HTTP colon or HTTPS colon, then the double forward slashes, and then anything that is not the forward slash. So what this will do is it will get only the domain name. So if we have www.beckteller.com / all this, so it will match only till .com, not anything after that. So this is because we are matching the first two double slash, and then we are matching any character which is not a slash as much as possible. So it will only match till the first forward slash is encountered. So this will work, but then this is a better way of doing this, which is we say that the S can either be present or be absent. So we can do HTTP S question mark, which means the S can either be present or absent, then colon // then the same thing. So we match as much as possible of any character except the forward slash character. So we match till the end of that domain.
So if the question is opposite, find the URLs, ignore the domain. So then that cap,
yeah, if you want to ignore the domain and the rest part of the
URLs only,
yeah,
the line containing the URLs.
Then you can do using the Perl regex, but that is not part of the syllabus.
Okay, fine. Then skip.
Yeah, sure. So the last option is basically same thing, but then here it's checking that it has to just be A to Z and A to Z. But then some URLs can also have numbers, right? So or dashes, as you can see here. So this will not work like that. So we use this B and C options only. Okay, given the following input, identify which of the statements present in options are true. So it's asking if BZEGR and BZFGR are soft links or hard links. So you can see BZFGR and BZBGR. So you can see it's a soft link, right? Because we have this arrow. Also, we can see this L. So BZFGR is a link to BZGR, and BZEGR and BZFGR, both of these are soft links to BZGR. So both BZEGR and BZFGR are soft links. So similarly, there should also be another question. Yeah, so BZL and BZM are hard links. So BZL is obviously a soft link. As you can see, there's an arrow and there's an L here. BZM, I think it was. Yeah, so BZM is not listed here. But then we can assume that because this was not a hard link, so obviously that option is incorrect. And then BZCat and BZip2 are hard links. So here you can see where is BZCat. Yeah, so BZCat is there and BZip2 is here. So these are not soft links because you can see this is dash and not L, and there's also no arrow. And BZCat and BZip2, you can see the inode number is also same. So it's 23 and 23 here. So these are hard links. So BZEGR and BZFGR are soft links, and BZCat and BZip2 are hard links. Okay. So this one is a script, and then we are asked. So this is hints, and then there are lots of hints. So for the script run.sh, identify the true statement from the following options. The bash interpreter used to run the file. The bash interpreter used to run the run.sh file. How is this a word? How is this a sentence? Yeah, so the bash interpreter is used to run the. So there should be a is here. Yeah, so the bash interpreter is used to run the run.sh file. So as you can see, the first line here is shebang bin bash. So the bash interpreter is used to run this. Okay, so a new directory is created at the end of the execution. So you can see here we are having a variable directory, a variable zip test, then we are reading a password, then we are basically using zip to zip something. You can see the man page of zip, how zip works. So the -p basically means password protect the zip. So you can like compress a file and password protected, right? So we can use the -p to give the password protection and -r. So let's see what -r does. So this will travel recursively. So everything inside that directory will be zipped. And so the synopsis is zip and then patterns and then zip file. So, and then the destination, do we give the destination? So zip file and then file. Yeah, so so the destination is given here and the zip file is also given here. So the zip destination is myarchive.zip and the directory to zip is the my directory. So this will obviously not create a directory, but it will create a file, which is the zip file. So it will zip the folder and create a zip file. So it's not creating a directory, but a zip file. So the zip file is password protected, yes, because we use the capital P flag. The password for the zip is password, I think no. So the password is whatever the user inputted. So we don't know what is the password. So whatever the user inputted, then that is the password. But then it's not the word password. It is whatever the user has inputted in the std. And password for the zip cannot be obtained from the given script because it is read from the standard input. Exactly. A new file is created. Yes, the zip file. And if is replaced by read zip, then output file name is obtained from the second line of standard input. Okay, no. So it is obtained from the first line of standard input. So if we make this a read also, so the first read will be of zip dash and the next read will be of the password. So it won't be the second line, but it will be the first line. So that's why this option is also wrong. Okay, so there's this after this, there's this question on cut and sort. So you can see that the sorts man page also is given. So if you're lucky, like the man page will be given, but then do be prepared with like some of the flags of it. So things like -r for reverse, -n for numeric sort, etc. So which are used frequently. So here you can see similar things. So the etc password file is there. So the following are the contents of a password file. What will be the first line of the output of the command cat etc password, cut by the colons and take the first third field, right? So this 0, 1, 2, 3, etc. and sort rn. So here you can see we are sorting in reverse order. We are sorting numerically. So what will be the first line? So basically what is the biggest number in the third field? So you can see the biggest number in the third field is this one, right? 65534. So the answer is this one, 65534.
Here they have used the n option. Here they have used the n option. Here they have used the n option.
Yes, here they have used the n option.
Otherwise, if n is removed, then we have to choose something like a 9, right?
Yes. So yes, then the answer will be 9. Yes.
Yeah.
But Sayan, here we are not using -k. So
yes,
we are
already
not
cutting,
defining the field.
Yes, so we are already cutting.
Okay, we are cutting the.
Yeah.
Okay.
So first we are cutting, then we are sorting. So the entire line is just that. So it is fine. If we did not cut earlier, then we had to give -k3 and then -t colon, both the parameters we need to give, so that it can sort using that field. Then if we cut, then we get that answer. But because we are cutting earlier, that's why directly we can sort. Yeah, so nice question actually.
So means we have given -d option in cut, because of which we are not giving -t after sort. Is it so?
Yes, because already we are cutting, right? So this file, once it goes through cut, it will just have these 0, 1, 2, right? So that will just be the output of that. So because we are sorting on that, so we don't have to give the which field to sort by.
Okay.
Yeah.
Either we have to use this or -t dot.
Yes.
Okay.
Okay, so in this question, this is pretty simple. So you know that 1.11 will expand to 1 to 11. So one thing to remember that this will include both the left and the right side. So this will expand to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and also 11. So can we use .* in place of, yeah, I think we took that, right? Yeah, you can use .* also in that email thing. Yeah, so here this 1 to 11 will expand to 11 numbers. So 11 will also be included in there. So we are running 11 sleep commands in the background. And then this 1.11.2 basically means we are running 1, 3, 5, 7, 9, and then 11. So all the 6 numbers. So this will basically run 6 times. So 11 times we are creating a sleep, and then 6 times we are killing the last command. So only 5 sleep command will be remaining. 11 minus 6 is 5. So the answer is 5. One pattern found. Yeah, the team loves Etsy password file. Yeah, exactly. So you may have it, you may not have it also. So let's see. Okay. What will be the order of the following? Read n for line. And then take it from this echo ABCDEF. So this will, what this will do is it will print this echo ABCDEF, and then that will be given as the standard input to the read. So this is same as echo ABCDEF pipe read dash n for line. So this way of running something and giving it as if it's a file input to the stdn is also another way of giving input. Right, so what N4 does is it will read only 4 of it. So ABCD will be read. So if you print it twice, it will be ABCD, ABCD. So that should be the answer. Where is the answer? Yeah, ABCD, ABCD. So you can see the help page is given to you. So if you see in the read, so we also have a hint. So if you do, so it's also telling you how this thing works, right? So if you just pipe it to cat, then it will just print 1, 2, 3, 4, 5, 6. So if you pipe it to read, then read will read that and store it in the line variable. So the read dash n, if you see here, dash n means it will read only the n characters. So only the 4 characters are read. So ABCD are read, and then it's printed twice. So ABCD, ABCD. Okay, so that marks the end of this paper also. So yeah, I'll not do any other paper today. So we'll see in 2023 September and 2023 May. So do go through these 3 also, 2023 Jan, 2022 Sep, and 2022 May also. So you can get these in this ACE grade website. So there might be other websites also. You might get it in your WhatsApp groups also. So you will know best where to get them. But then, yeah, so just go through the PYQs. So it will help you prepare for the quiz. Yeah, Trisha.
Sir, I have
Yeah.
a doubt in
Yeah.
September 23 paper.
We
That
saw
grep
September
thing, sir.
23. Yeah. September. Sorry. Oh, Sept. Yeah, which one?
I guess second question, sir. I don't.
Second question. This one.
Not this one, sir.
Okay,
The next two.
This one.
Yeah, this one.
Yeah.
Yeah. In the first option, it says we are matching. I mean, like we are printing those lines, which doesn't match with A to Z. I mean, the pattern which is given in the square brackets. So, in the question, they are saying that we have a number, only one number which is hidden. So there can be alphabets before and after to that number.
Yes.
So it won't match if we consider that thing as well, right?
No, it will match, but it will print that entire line. So what this will do is it will match this number. So you can say, I think the number is this one. So it will match this. So what it will do is, this is the entire file. If you run this first option, it will not print all these lines. It will just print this one line, and it will mark this as in the red color. But this entire line will be printed. But what I want is, I just want to print this number. So for that, we need the dash O flag, right? So if I give the dash O, then only the number is highlighted. So this one will also work if I have a dash O along with this.
Okay.
Yeah.
Okay.
Yeah. Also try this out. Like just create a file like this, like any file according to you, and then try out all these different ones. So try this, and then try this with dash O. Maybe try the second one also, and obviously try this one.
Okay. So any line matching with the substring of the pattern, it'll print that line in the output.
Yes, it will print that line, and the matching part will be red. But if you just want to print the match, then you can use the dash O.
Okay. Okay, sir.
All right, yeah. So I'll stop the recording now and I'll stop sharing.
It is a marathon session.